right? So then you do all of those things. Ultimately, a neural network has sort of like descended through the gradients, and then it's found the optimal of the function, and then you give it new data, and then it's able to predict what the outcome of that function would be given that new data because of what it learned from experience. So that's sort of like what deep learning does. Being polite to a model doesn't make it better. So, for example, saying please to ChatGPT,
and thank you.
It has nothing to do with anything. But yeah, so this prompt engineering became a new role in that context, that the way you prompt the model. So this new obsession with using AI for novel, fundamental scientific discoveries, it's important. I think once we get like the ChatGPT of these scientific fields, in a way that, do you see how ChatGPT is useful? It's a language model, but it works, So it's like if we get models that work in these individual scientific fields, then they can help us understand the nature of reality. Because we can't model all quantum particles right now, right?
Hi. Welcome to episode 3 of Real Geeks with Ivan Regasek. My name is Ivan Regasek, and today I'm joined by an old friend. Personality I think the world needs to see. A very special guy, and I'm looking forward to it very much. Mr. Mabu Manaileng. Apologize for pronunciation. Or just Mabu. He's the AI lead at Standard Bank Group. We've known each other from the hackathons. He's got he was top 15 geeks, so you still saw it on Google and your picture there, coming from the grassroots level. But maybe let's start with where you are now in the corporate. What can you tell us about your position? What are you doing? What are the challenges you're working on? What are the projects?
Yeah, sure. Thanks for having me, Ivan.
It's a very much pleasure.
It's always nice talking to you, coming from back in the days.
Sure.
And yeah, I'm very, very much glad to be here on your podcast. I'm a very great fan of it. Love your company, what you do, your passion with the hackathons back then as well, and also now. So yeah, I think we're friends for a reason, because we share some passions.
Yeah.
But yeah, so I mean, from being that hackathon boy back then with data wizards.
Yeah. Yeah, let me interrupt you. Yeah, this is Real Geeks, and that's why you're on here.
Exactly. Exactly. Real Geeks indeed. But yeah, so from being that geeky guy back then with the hackathons with our data wizards team and stuff, obviously been a lot more consumed by corporate now. So I work for Standard Bank, and then at Standard Bank I lead AI engineering under the personal and private banking division. I work for a unit called the Personalization Center of Excellence. We basically work on everything personalization for the clients. So that would be both like private lines and just the normal clients across different segments like affluent, mass market, and those kind of things. So we would do product recommendations. We would so we build the models that will do those things. But my main focus is on the engineering side of it, which basically means, I always say this, that data science or machine learning or AI in general, it's no longer a scientific problem. Like the reason we call it data science, because it was a bit of a science. Most of the time, you'd be focusing on, the insights out of the data, trying to build the models and blah, blah, blah. But then as data science evolved, it became much more important to look at it as an engineering problem, because once the science is done, what happens to it? Once the model is built, how does it get to production? How does it scale? How does it make like recommendations to customers in real time, for example, or at a big scale, for example? So this is not typically a data science problem, worrying about engineering, worrying about infrastructure, worrying about scale, because data scientists, usually would be worried about building the models, worried about getting the model right and the data right and stuff like that. So actually, funny story of how AI engineering my team had to came about at Standard Bank. It's like, once I started like being too opinionated about this engineering thing, I mean, and it was inspired by many things. So, for example, Gartner, which, they're famous for their 4 quadrants of innovation and stuff, the American consulting company, they published like some statistics some time ago, a few years ago, that like 80% of models don't go to production. So I think I remember at the time I was when this was like really vibing in the corporate sector to say, what is the problem? Why can't we get this? And that's true, by the way, because many companies obviously will always say that they're doing data science, they're doing AI and blah, blah, blah. But if you like open it up, very, very few companies are actually doing proper machine learning in production.
Well, the issue is the skills, right? It's very hard to do.
And because when data science became the sexiest job in the world, there was a spiral of people hiring data scientists left, right, and center, right? But what we missed was that the data scientist should come with support of engineering capability. So many companies had a lot of data scientists, but now they're just building Power BI dashboards. They're not really doing valuable, like Google grade type of AI. Because it's like, if you look at like what type of AI they do at Google, right? It's like, it's real time impacting customers. In South Africa, you still have like nervousness with people who feel like, can I really unleash machine learning, proper machine learning or AI to face my customers without me intervening in between? But these companies that we get inspiration from, they've been doing this for a very, very long time, right? I watched some documentary about PyTorch. PyTorch is the machine learning framework that Facebook built and open sourced it. And then they were just talking about its evolution and how did it get about. But then they mentioned that it allowed them to do like 1 billion inference a day at Facebook.
What's inference?
So inference is when the machine learning model is predicting given the customer's thing. So for example, you can imagine...
So 1 billion predictions a day.
Yeah, 1 billion predictions across their family of apps. So it's like, that's when we talk about machine learning in production, that's the kind of like mind-blowing scale.
The numbers that you want.
And it's like the fact that they are doing it with an open source framework that I have access to is where we're saying, why can't we? So because it's open source, it's like, so that's when I started thinking a lot about this, to say we need to really improve our cadence of, as a bank, our capability of being able to run engineering, like large scale engineering projects in the context of AI, right? Because remember, Standard Bank, we have visibility across countries and all of those things. So it's like, back then I was working for the CDO, so it was the Chief Data Analytics Office, and then focus on data investment. So the idea was exactly that, to say, how do we use technology to get proper, monetary value out of data? And not just monetary. Sometimes you use data to improve your customer experience and stuff, and that's valuable to the customer. But a happy customer is a happy business anyway.
It's less tangible on the amount of money, but it's
yes. So then we agreed with the CDO at the time that we should really start reimagining what we're doing with AI across the group, because it was a group function. A CDO will be the division in the company that is responsible for data and everything data related. So then I proposed the idea that we should create like AI engineering roles to the CDO at the time, and then we were like, what would be an AI engineer? What would they be doing? And because I know if it's time I say I'm in AI lead, in AI engineering lead, it's like, what is AI engineering now? How does it differ from data science? How does it differ from this?
Yeah. I also want to ask.
But it's so the difference is so basically, and you'll see now that even companies like OpenAI, Microsoft, and other companies that are our inspiration, they literally would advertise like an AI engineer now. They would say, we're hiring an AI engineer. But so this whole data science thing, as it evolved, like I indicated, it became less of a science and much more of an engineering problem. So it's like, if let's say you are a data scientist, you train a logistic regression model that predicts whether a customer is going to take a credit card or not. So now I'm like, oh, this model works. This is nice. And how do I deploy this model so that all the customers that qualify for a credit card limit increase can get an increase your limit notification on the mobile app? Okay, what is my customer base? Standard Bank, we have like what, 14 odd million customers? And if not 12, I think it's 14 or 12. Don't have the exact number. But it's like, now you have to scale it out to that. I mean, sometimes you may say, no, let's segregate and say we're only going to target the following kind of customers. But you see now what we're talking about, it's no longer a scientific issue. It's more like, what kind of code should I write for me to scale to this level? What frameworks? What is that? You start worrying about latency. You start worrying. So those things data scientists are traditionally not trained to think about. And when you have an engineer, an AI engineer, you have somebody who thinks about those things natively, but is also a data scientist. So that's what basically how we imagined what AI engineering should be. So you will start from sourcing business requirements, understanding what the business problem is, solutioning the problem so that it becomes a data science problem. Because when business comes to me, they speak in plain language. I still need to convert that plain language into what kind of model, what data do I need, what features would be useful, and that kind of thing. So you have to have that skill. And then once it's there, you need to think about inference, predictions. How do I deploy this in a way that can make predictions at scale? Worry about that. And then once you start worrying about that, you worry about what is the infrastructure. So for example, would it make sense for me to distribute this on a Spark cluster, for example, to do inference? Or should I just have like spin up a GPU and then do inference on that? Which one would cost more? So all of those complicated decisions.
All those things.
Yeah, you think about DevOps, you think about CI/CD, I mean, and it actually translates to small little things. So for example, in Python, when you write, I mean, most of machine learning stuff we do them in Python, whether on a distributed cluster with Spark or that kind of thing. But it's like, even when you write Python code, so there's things like PEP8, which are Python standards. There's things like, advanced topics like type hinting in Python, like docstrings and linters. A data scientist doesn't really want to be thinking about those things. They just want to write code, and the model is trained and it's working for good reasons, because their job is to think about the science. But like I said, so as it evolved, you could get somebody with a PhD in physics background who's doing data science work. So you see now that when the industry becomes like that, where it's not monopolized by I'm a computer scientist, I'm a statistician, but it's like anyone who can apply their minds can do the data science, then you see now that the industry is all sort of, it's changed now, and then it requires skills beyond what we initially thought a data scientist should do.
So being a data scientist is not good enough anymore. Knowing what statistical regression is in the first place, that's
not good enough anymore. It's contextual. It's contextual because, so for example, it's like, depending on what business problems you're solving, the skills you need are very different. So if you're a research lab focused on trying to come up with a new way of doing regression or something, then you probably need a PhD statistician who's going to think about those problems. But if I'm a bank and I want to sell products, I don't want to think about those things. I want to know that the API will be 99.9% available. I want to know that I'm not going to have downtime. I want to know that I'm not going to trend on social media for my banking facilities not working. Right? So that's an engineering problem.
And I want to know how much those servers are going to cost me.
Exactly. How much money can I make? and that kind of thing. So interestingly, the CEO of Anthropic, Dario Amodei, made an interesting comment where he said that they found that when they hire for AI engineers, like the people who build like Claude, their model, their version of ChatGPT is this Claude model. that when they hire people to work on in their company on those kind of problems, usually they find that people with a background in physics are the ones who quickly adjust and make significant contribution. And this is a physicist who technically should know nothing about AI, but when they get into this AI company, they are very able to, very quickly contribute to even the research papers, not just the deployment of the app, but the research papers that they publish. You'll find 2 or 3 physicists there as co-authors of that, talking about AI, but coming from a physics background.
How does physics? Because like I actually really want to learn about this stuff today. But my initial impression and the evolution of this sort of stuff, I tried to have a look, and I kind of. But when we first met and you were talking to me about this stuff, you were using those words, statistical regression and whatever, and it all seemed like advanced statistics. Like,
yeah,
I did a little bit of it at university, but it was, which is a difficult skill set in itself. But it you need to kind of be an actuary and a statistician to understand what input. It's not a lot of input that you need to give the models, but I guess you need to be very smart with it. Then a couple of years later, I tried to dabble in some JavaScript stuff because my Python's not great. And to kind of test my understanding of machine learning, because I was kind of the part that I understand, I don't know if it's great, or how it is that they eventually just guess the functions.
Yeah,
it's mass that they're guessing, and then eventually they'll get to the by randomization of functions, or however they'll get to the right function, and in the background that's somehow how it operates. So then I tried to give it a function, a simple function, to guess it for me, to train it. And it was a number times 2, double it. And then I feed it 1,000 numbers, and I don't know, ask for a projection, it's all wrong. And then I don't know, fed it more, I guess, until eventually I gave up and it wasn't coming close. And then I was like, I don't really understand how this works, because it's a very simple function. I should be able to guess it. But recently I saw on your LinkedIn you say that they are bad at mathematical. That this is like a function that would be bad at guessing.
Yeah, it's an interesting.
It's great.
It's an interesting trend. So these guys they studied. They took the latest OpenAI models. So this is a bit of a different subject because this is strictly LLMs now. We're talking about LLMs, which would be large language models. So the argument has always been that large language models are not good at mathematics. So the critics, there is a famous guy called Gary Marcus, who's always like criticizing the Jeffrey Hintons of the world, the Ian Goodfellows, the Jan LeCun's, to say that this deep learning is not gonna get us to artificial intelligence at all, because what we're doing is just not intelligence. Because the way machine learning works, it's basically, I mean, I like that you use the word function, but it's basically that. It's basically just learning the shape of a function. But with deep learning, I mean, with regression, it's very easy. So, for example, you can learn the shape of a linear function, and then when you do that, you can be able to say from this dot, I can predict the next dot is going to increase by, let's say, let's say +2, and then it's going to go from 3 to 4. Then you know what I mean.
That's why I also thought it would be easy, because I mean that was like
you can build
perfectly straight
a decent regressor. You really can, especially for regression. It's you can really build a decent one. Even for like statistical functions like ARIMA models, like autoregressive moving averages, have been used to make like really convincing forecasts, for example. So those kind of, whether they work or not, we know that they do, and obviously we can also measure how good they work and that kind of thing. And we can also interrogate them. We can interrogate a regressor to say, how did it make this decision? Or tree-based models, you can do that. But deep learning.
How do you interrogate them?
So for example, if you take a decision tree, you would have features in the decision tree. So suppose we want to predict the income of a person. Then the features would be, let's say, we typically don't like demographic features because they can make machine learning models biased. But I mean, I always argue, like, my team and I were always in contention about this to say, for example, can we use somebody's race as a feature in a model? And I'm like, in South Africa, race is a very good determinant. It's a very good predictor of many things. But it's like, regulatory speaking, we don't like that. Like, the regulators don't like it because, like, you end up, giving, men more products than women. Then the model is absorbing the problems with cultural things. Do you know what I mean? But anyway, you have a bunch of features. Suppose height is a feature, and then maybe let's say your where you stay, your education, and blah blah blah. Yeah. That's the feature space you're building.
Income, blah blah.
Yeah. So we want to predict your income. So the income is the outcome. Okay. Right? Okay. Then what you do is that when you fit it to a decision tree classifier, decision tree regressor, because it's a number, so regression will be numbers and classification will be like categories, right? So you would say, okay, if your height is greater than this or less than that, if the region of your area is this, if you're that. So it's actually the machine learning model internalizes the if then else statements, but it internalizes them. So you don't have to write 1 million if then else's yourself, but the model creates that. Then the way you interrogate it is just to say, you can literally draw how the decision was made. So if it predicts that your income is 1 million, then we can go back to the tree. Then you literally see that because his height is more than this, then the model decided to go this way. Do you know what I mean? So that's easy. You can do that. And then there's other complex ways like calculating Shapley values. And there's like statistical ways of doing things like that to interrogate what the model we usually call it machine learning interpretability. It's a difficult problem, especially for deep learning. So in deep learning, we really don't know, like, why did the neural network decide what it decides, right? And the problem also is that because we're saying you're learning a shape of a function, when in deep learning we project the function in a hyperspace. So that means it's very highly dimensional. And we don't know the dimensions. It's like, if you try to draw, like, for example, there's these fun animations you can do with what we call gradient descent, because we basically use the algorithm called gradient descent to descend through the function for us to find its like minimum. If you try to visualize it, you can see that the shape, it's actually super complicated. I mean, some functions have like multiple minimums. So for example, the way we try to visualize it is that you can think of a function as a hill. So let's say a mountain that goes like in multiple directions. You want to find the lowest point in the mountain. Then let's say you roll a ball. So the ball is going. And then throughout the rolling down the mountain, you can find somewhere where the mountain seems like it's the end of the mountain because there's a bit of a thing. But if you pass that rock, let's say, and then go down, you're still descending the mountain. Sure. So if you get stuck on that rock, we'll say, you're stuck in a something. And then you need an algorithm to the gradient descent algorithm to be able to know or figure out that where it's stopping is not the end of the mountain. And that's difficult. I mean, people came up with many things. And there's difficult problems as well. Like, for example, if you're rolling the ball, how many steps should you take to go to the next point? I mean, this sounds trivial, but it's actually somewhat complicated. So you can imagine that you could, if you step over too much, you could miss a minimum, because what you could do is that you could, if you're jumping too much, you could miss the minimum that was there and then you on the other side or something like that. It's difficult to visualize. But that's where things like...
If it's difficult for you, it's difficult for me.
Yeah. That's where a concept like adaptive momentum comes in, where people figure that as you descend the mountain, you should change your momentum. So you shouldn't have a fixed momentum, but you should regularly adjust it.
Okay, the ball will change the length.
Yes. So sometimes it will go faster or higher in a jump, and sometimes it will go smaller, contextually depending on where it thinks it's on the hill, right? So then you do all of those things. Ultimately, a neural network has sort of like descended through it, the gradients, and then it's found the optimal of the function, and then you give it new data, and then it's able to predict what the outcome of that function would be given that new data because of what it learned from experience. So that's sort of like what deep learning does. But the problem with deep learning is that, and remember now, when we say deep, now like we're talking like so deep, it's actually shocking. I remember as a graduate student, I did my research in artificial intelligence myself, and then we're building models to recognize speech and language models as well. We looked like idiots at the time. Like
you have research papers on that.
Yeah. People didn't really. It was actually quite depressing, and it's not that long time ago because I graduated 2015. So my research started 2013. So I did a 2-year full year master's degree. And at the time, and this is 2015, it's not that long ago, but at the time, we're even calling the neural net ends like ANNs. So we call them artificial neural networks. So it was ANN. So in the research space, we would have this language that we were using, and we couldn't build proper neural nets at the time. Well, at least, especially like in South Africa, because Americans have been trying to do this, and obviously they had the know-how, they had the hardware, they had all of these things. So, for example,
the hardware is a big one. I think a big equalizer is kind of cloud and the ability to also...
Yeah.
Because at least from my perspective, it kind of felt like there was a ceiling. I'm eventually going to host it like a small local hosting the previous ones before cloud, and that wasn't going to work like Google or Facebook. I really love your attitude that you're like, why should they be better?
Yeah. Of course.
And especially now that you can get access to
an API, right? Then they host an API. It's running on their infrastructure that you can be able to do some Facebook-like things because you're consuming the same type of inference. So yeah. But anyway, I think that
you can scale it up to that scale.
You can if you can afford it. But one of the things that we're also seeing is that the more advanced the models are becoming, the less costly they are. Also, what's happening is that so there's a new revolution called SOML.
So how expensive is it to train one? It's very expensive to train them.
It's prohibitively expensive. So I think when they trained GPT-3 or GPT-2 or something, they spent like some $40 million or something. It is coming down the cost, especially because people are building like customized chips now. So, for example, Google has tensor processing unit. Microsoft has a programmable gate arrays and stuff, what they call FPGAs, field programmable gate arrays. So this is hardware that's designed to do tensor processing. So tensor processing is basically matrix multiplication. So they're building the hardware so that it's only specialized in that. And because of that, then you can cut down the cost of training and inference. And yeah, but you're right, hardware is a big issue. But if you look at like the new GPUs coming out of NVIDIA as well, and the reason why NVIDIA became $1 trillion company is because hardware. But yeah, so
we're kind of in evolution. So I kind of, the stuff that you're talking about, I understand that as a data scientist. It's like stuff which is beyond my knowledge in terms of like practical business application. I actually heard a new term yesterday. Kate Metzi actually says MLSecOps is a ML security operation.
It is
a new thing, but like from my perspective, the world is a application developer. It's not that landscape. Now when I'm looking at machine learning and I go into Google Cloud, for example, there's like a model garden, too many to, that's a little bit confusing because now, okay, here's 100 models and but many of the things are plug and play.
Yes.
So now without a lot of cost, I can start just using their services and APIs, predefined models that they built out of their model garden. So it's quite easy for me to consume. to solve that sort of tech business challenge, apply the technology to solve a business problem, without worrying about any statistical regression, any statistics at all.
That's so. I have multiple views about that. Ne? So I think there was a revolution that started called AutoML, and that's what you're describing, where the idea was that all you have to do was give this system your data, and it's going to build a model for you. I honestly don't know how many people have like production grade ML models running from AutoML. My experience with it is that it's kind of nice for experimentation. But there are certain limitations, and
but it's not really making your own model, which you can, I think, still do. But I think the basic use case is just consuming models, Google models, in pre-built, consuming them via the APIs and with your own data. And
so that's the new face of AI these days. So AI is an API call away, but if you go back a bit, you would have AutoML models platforms, and AutoML platforms were saying, like this one called H2O.ai, it was actually quite famous for. So the idea was it takes your training data and then builds different types of models for you. That's like what we call hyperparameter optimization, and then searches through some grid search stuff, then find the best performing model, and then says, this is the one you can use. Then give you tools to export it as an API or blah, blah, blah. Do you know what I mean? So that's what we call AutoML. I mean, right now, it's sort of like auto AI. It's not auto ML anymore, because there's no model being trained that you can export and then deploy somewhere for inference. It's like you're just getting predictions out of the models without. I mean, if you want to fine tune an LLM, for example, that's okay.
Yeah. But you see, it's very, in terms of practical business value, that's ultimately what you really want, and you can solve some problems. I can have a long list of problems that I wasn't able to solve through technology before. They were just too difficult, but you always kind of wanted to be very useful for a value proposition. But now I can't. I just need to find the time to apply them and integrate them into our systems.
So in actual fact, I call so one of the things that I think it's a bit of a controversial opinion for me, because I also struggle with it a bit sometimes, whether what my actual view is, has always been that we are gatekeeping AI and its capabilities with qualifications. So it's always been like computer scientists can do AI, like PhD mathematicians can do AI, or that kind of
physicians.
Physicists.
Physicists. Sorry,
but it's like I'm not convinced that's the case. I don't think that just because you don't have a PhD or just because you didn't study statistics or blah blah blah, you cannot do AI. I call it the democratizing technology, because it's like, so for example, even in South Africa, across like race and gender spectrums, like, so for example, it's very rare to find females in certain areas of technology, simply because they've been historically excluded from those areas. I mean, even for example, you may say, I mean, it's now in South Africa, it's many years after democracy now, but you may say that even in the past, you would find very little black people in a certain area or sector of technology because they've been historically excluded. But in AI, no one has a history of AI. So it's like now there's no advantage. So if you're a lady and I'm a guy, I don't have any advantage over you because
But you do have a history of exclusion from education. You still don't need.
That's a
you need
point.
Good education to. I mean,
but okay. Suppose that you have a high schooler who is a university dropout. Ne?
Yeah.
I know many people now who work for banks. I mean, I advocate for this all the time. I always fight with our human capital partners in the bank where I'm like, guys, is it really necessary for us to say you must have a degree? But I know degreeless people that are very solid software engineers and very solid. And with this AI thing now, because AI is an API call away, somebody who doesn't have the master's degree in AI that I have can build a very compelling AI product by connecting API calls and this and that, and I don't, because my degree doesn't give me an advantage over them.
Yeah, but it's also lifelong education for all throughout. I'm also a big believer that, because most of my skills, I value education and saying, that it has the test of time and it will always be there. That, I don't know, I become, but that's not really where I learned my coding, and it's all. So yeah, I agree with you on that.
And also, I think we should also remember we need to have new ways of thinking about what education is. So in the past, think about this in the context of shopping.
Yeah.
So in the past,
self-learning and
yeah. Shopping used to be that I need to go to a brick and mortar store, buy something there, go to the till, come out. But very quickly it evolved into I just click buttons on the internet and then I'm okay, So education is like that. I think it was Elon Musk who said that the internet is the biggest college, which is true. So education does not mean you went to university or you went to some college. You can get educated without a college. You could literally do like an online Coursera degree that's being taught by an MIT professor.
Mm-hmm.
I'm still educated. Do you know what I mean? And but if we get stuck to the idea that we need your university certificate, we need your degree, we're just excluding talent out of the talent pool that we don't have to begin with. So I think people should really be open-minded about tapping into the talent non-conventional.
If there's somebody like you that comes along and let's say, for example, you didn't have the same degree, it would be very silly to say, you don't have the skills.
Do you know what I mean?
Yeah.
And one of the things I really enjoyed about our hackathons back then and geek culture and them is that it was actually for that. I know many guys who used to do those hackathons who don't have degrees, or who have degrees that are not coming out of tech, that were able to be techies and then work in proper jobs in software engineering, for example. So yeah, I have a master's degree. It's kind of like it's a bit of a double standard to be saying I don't think these degrees are important when you have them. but I honestly don't. I don't think you should think of a degree as something that will.
There's the joke in Silicon Valley, like you must drop out of university.
Oh yeah.
To be successful, you mustn't have a degree. You must be a professor.
I'm not encouraging it, right? I'm not saying people, if you're in university and you like it, you should do it. But what I'm saying is that if you really want to get into building cool AI products and stuff,
it's lifelong learning.
Degree is not what you.
It's like my view is the way that tech is evolving and stuff. If you want to be on top, it's lifelong learning. It's daily. You have to.
So interestingly, I actually have people reach out to me on LinkedIn saying, "Hey, I come from this background, but I want to get into data science and AI. How can I do it?"
Sure, I'm sure you get asked that a lot. Yeah,
I did. It's a lot. It's actually to a point where I designed like an online education program. Yeah, so that when they come
on website.
No, it's not on our website. It's just like when they engage me, I'll be like, start here and then do this and then do that. One of the things I find is that people try to do this online, but because they don't come from a data science background or a computer science even, they don't know which certificate to do after which one. Do you know what I mean? So there's no ordering of like, there is a website I like called DataCamp where they create what they call career tracks. Yes. So they will organize them for you. They'll say, if you want to be a data scientist in Python, start with the following thing. And that's super helpful because then somebody who doesn't know where to start, then they follow that program. But I do that. There's a lady who had a BSc in soil science, biology. And then who said, I'm frustrated with this thing. I don't know what to do with it. Can I pivot into? Then we went through some rigorous training for a couple of months and then gave it some projects, gave it, we call them MOOCs, massive open online courses. So gave him the courses to do online, most of them free, some of them with Coursera where we have to pay. And then prepped her for an interview. And now she's a manager, a data science manager at a consulting company with a biology degree.
Oh, sure. So once you learn it, you can also get accredited. You make a little bit of investment.
Yeah.
And then I'm sure you'll be able to get a job.
And then at Standard Bank, in my job now, it's a team of a couple of skills, right? And we actually like take care of some what we call add-ons on the Standard Bank mobile app. So on the mobile app, we have what we call an add-on store. You can think of it as an app store. So you can install cool stuff that are built on top of the app.
Okay. Who is it open source? do devs do it?
No. We
It's not internally.
Yeah, it's internal. It's on the mobile app. Like when you log into the banking app, you can go to the store and then you'll find things there.
Yeah. But these apps are created internally.
They are created internally. And then so we take care of what we call digital money management. And then, so we will show you your credit score and tell you where to improve with tips and stuff like that. So if you have that feature on the mobile app, we take care of something called feature payments, where we predict which payments are coming so that you can manage your money very well. So if we predict that your feature payments are going to be 30,000 and your current balance, it's this, and it's going to improve, then you obviously need to do something. So we give you those early warning indicators. We have budget manager. South African people they're suck at budgeting. So we try to use machine learning to predict what your budget will look like given your historical expenses. Then, you have a pre-populated budget when you log into the mobile app, and then you can adjust it here and there. We have like money movements where we're tracking where is your money moving. So for example, your income versus your expenses, and your income, where is your income coming from? Is it just salary, or do you have regular payments? Where is your expenses going to? Are you spending like 50% of your income on groceries or on entertainment? And it's super valuable to clients.
Sure.
So those things are mission critical applications because they are on the mobile app, and we don't want a widget not working or an add-on not working on the mobile app. So that means the team needs to ensure that deployments are taken care of properly, which is where engineering becomes important, right? Because you don't want to make...
Yeah, I want to go back to that, because also a few months ago, didn't attend all of them, but also in the kind of quest to do, okay, let me do a little bit of learning about this stuff again. I did they had Google Cloud training courses, but I didn't really finish it. I only attended a couple, but they were talking about prompt engineering and prompt. They used another word, like it's 2 new jobs or skill sets.
Yeah.
It's actually just kind of the example was that it'll give you much better answer if you first give it the context that you, like let's say if you ask it some question about Google Cloud, first give it the context that you're a Google Cloud engineer and you need to answer X and Y, then it gives you a much better answer. So kind of just about formulating the question.
Yes.
Yeah.
Yes. It is a new role.
Which isn't obvious. I don't know how difficult it is, but...
So, ironically, the larger we build these models, the less we're going to need prompt engineers. So what we are seeing is that as they scale, the prompting doesn't make much of a difference. But the current versions, there is a huge difference. Also, especially like generative models in the image spaces or video spaces. So the prompts make a huge difference. Actually, there was a funny example. I read this paper where they published, they were investigating different ways of prompting models. I mean, earlier on we knew this, but before the paper discovered other things. But earlier on we knew that if you told the model, imagine that you're Einstein, it gave high quality answers better than if you said you're not Einstein, right? So the attitude that it assumes makes it even more clever.
Right.
But then this paper found that if you promise the model that I'm gonna tip you $40, then it give you better answers than if you
Really?
Yes, it was super interesting. And they also found that being polite to a model doesn't make it better. So for example, saying please to ChatGPT,
and thank you.
It has nothing to do with anything. But yeah, so this prompt engineering became a new role in that context, that the way you prompt the model. And I've seen this myself. I mean, what you were describing in terms of giving it context can be scaled as well. So for example, you can give it context that imagine you're a Google AI engineer or something. That's okay. That's just what we call a system prompt. But over and above that, you could actually build what we call RAG systems. So these are retrieval augmented generation systems. So the idea is that you when you ask a question to the model, you search what is relevant to that question to the model. You search it and then you pass it to the model, and then you say, here's a question, here is what we think can help you answer the question. Then the model will find the answer. This is actually interesting because in my history at Standard Bank, I think I've been doing language modeling for a very long time.
How do you search what's relevant to the model?
Yeah.
Through your own data or through another model? Or...
So the way it works is that you imagine that you have a body of knowledge. Say, let's make Google as an example. So you have a body of knowledge. That body of knowledge is the entire internet, because Google indexes the entire internet.
Sure.
So then, and funny enough, Ivan, back in 2021, you and I were speaking about a project like this actually for search. So typically, we used to call it semantic search. So semantic search, the way it works is basically saying, instead of doing traditional things like using keyword lookups and stuff, what you search, what you do is that you search in a semantic space. So the semantic space is very important because we don't use keywords, we use meaning. So some clever people found that you can train what they call word embeddings. Early ones were this famous ones called Clove embeddings, but later then we had many embeddings. So now embeddings are not a difficult problem anymore. But what an embedding is really is that you take a word and you project it into an embedding space. So basically you make it a vector. When the words become vectors, they become very interesting because vectors have very interesting properties, right? A vector has direction, a vector has magnitude, and then a vector, you can compute very interesting mathematical operations on vectors. So, for example, you can do a dot product of vectors to get how similar they are. So you can do cosine similarity. So, for example, the way you think about it is that if you have a vector in some three-dimensional space, it has a direction, right? So if you wanted to know if two vectors are pointing in the same direction, you can compute a cosine similarity between them. So if a vector is pointing that way and the other one is pointing that way, then the cosine of their angle is going to be different from if they are pointing the same direction.
Okay, so it's not just statistics, it's a lot of geometry as well.
It is actually geometry now, but it works. So the way then that would translate into a semantic search is that if I have, and this is actually the engine that we're trying to build back then in 2021, so that I think we're going to try to say the search on your website, when you're searching for articles on the website, it should retrieve semantically relevant articles to the search, not the keyword stuff, right? So the way you would do it is that you take all the articles you have. Imagine you are just only taking the summaries. Maybe let's not say summaries. Usually when you write articles, you have a title and then you have a blab, like a small. So let's say you take the title and the blab. Then we take the embeddings of that. When we take the embeddings of those things, then we project them into that vector space, right? Then now we know if I look at the vector space, I will find every vector will be organized such that if there's related articles, the vectors will be close to each other. If they're unrelated, they'll be their direction will be not close to each other. Then when a user is querying, so suppose then a user comes and say ITWeb Security Summit. So I want all articles that talk about that. What I do is that I take that your search, the user's query, I project it into a vector space as well. Then I compute a dot product of all my articles against this incoming vector. Then my dot product is only gonna, or my cosine similarity is only gonna return the most, so the vectors that are pointing in similar directions. Usually we use a top K. So for example, return only top 5 articles. Once I have that, then I say, I know that these articles that were returned by this computation are related to the user search. And because of that, I can then send what the relevant articles together with the user's question to the LLM to say, answer this question given the following context.
Sure.
Then suppose the question is, when was the last blah blah blah? The model will know how to find it. But
you see, if it's that complicated, that's far beyond my skill level. So if that's what it required for me to actually implement it, I wouldn't be. It is actually, we have implemented something for it, and that's kind of what is maybe an example. Because kind of solving it in that way, for one, you need to know what a vector is, and you need geometry. Then you need.
Okay, but
there's a lot of things you need to know, and those stuff you said that won't make a lot of sense to a lot of people. But we have kind of improved our MySQL search. We now send it to Google Search and Conversation on the thing, so they're just billing us for.
Yes.
But the difference is kind of, you put in your own data set. That's the only thing you need to give it is the data set, and then you use the model, which is much easier.
That makes sense. That makes sense. So let me give you an example of this project that we did and the evolution of it, because I want to agree with you, and I agree with you. I just want to stress the point that the geometry, the stuff, they sound complicated. They actually, to do a successful rec application in the past, those are the things you needed to know. That, oh, I need to embed this. After embedding it, I know that I need to, because for example, sometimes doing a dot product, it's much more useful than doing a cosine function. Because for example, when you do cosine, you would only be caring much about the direction, but not the magnitude. But dot products will sort of maybe put the magnitude into context as well. And there's other ways of measuring distance between vectors. You can do that. But so the way it worked, and maybe just
did you say it's not complicated?
So I'll use an example of what we did at Standard Bank.
Well, let me tell you, I've been like sort of, maths always came easy to me. Always been excellent at it without doing much studying. It's complicated to me, so lots of people can't even, it's complicated.
Okay.
Yeah.
Let's do it this way. Ne? So I think roughly 2019, 2020, we had this use case at Standard Bank where we wanted to build something simple, an FAQ bot. Ne? This FAQ bot was meant to be internal, like facing employees, especially just in the risk space. So the idea was that, can we allow people to ask questions about risk and get answers instantly, instead of like sending an email to a risk colleague and waiting for them to reply?
There's a lot of risk in that.
Right? So it's like, can I just search for, if I wanted to know something like, what should I do if a supplier gives me a gift? Then the model must be telling me you have to declare it if it's more than this amount. Or those things are sitting in policy documents and in the minds of risk managers, and employees don't know about them. But we go through training every year to try and remember those things. But sometimes you really just want to quickly search that. So that's a business problem. It's like, okay, we can build that. Then we tried FAQ, where it's like, okay, let's collect a series of questions and answers. Then the question will be exactly what I just said now, and then the answer will be this. Blah, blah, blah. So risk managers are trying to build this Excel file that has the questions and answers. By the way, this is traditionally what FAQs were like, right? Even at airport, if you want to do a refund, if you want to ask a chatbot on the website, it's going to search with keywords and say, this is the procedure for refunds.
Yeah.
So,
but that is generally how you train the chatbots, right? Questions and answers.
Yeah. But you should not be doing that. Okay. And then so we started like that. And this is early 2020. So there's no ChatGPT. There's no, do you understand? Mm-hmm. The only models really that we have, it's the BERT-like models. Because remember, Google released this paper called Attention is All You Need. Then they released a paper called Bidirectional Encoded Representations from Transformers.
I don't remember because I never knew that.
Yeah, I think it was 2015-ish.
Okay.
Then this paper presented language models as we know them today.
Okay.
The fundamental techniques of that paper are still the ones being used today.
Sure.
In language models. There's like optimizations, for example, of the attention mechanisms and other things that people have done, but it's still traditionally the same thing. So now what we tried to build an FAQ, you built it, not doing great. As you would expect. I mean, most FAQs don't do great. I mean, I saw someone on the internet joking, who has ever used these chatbots on the website and then they gave them the correct answer? It's very difficult. And also at the time, we wanted something conversational. So for example, the model must handle follow-up questions. FAQ bots won't handle follow-up questions unless you design them in a very decision tree-like way where people do it. I've seen people do it manually and then it works. There's technologies out of the box that can do multi-turn conversations with FAQs and stuff. But we didn't have the budget and we didn't have the time. Then what we did was what you just described. But we ran into a problem. So for example, one of the first problems that came was that, how do we know which of the question is the user asking? Because remember, you have a pair of questions and answers. So what you should predict is, what is the question? Yeah. That's what you should know.
Because they're not using the same words, right?
Yes. And then once you find the question, then the answer is a lookup table. It's like, so then we were like, how can we predict what the question is? That was the machine learning problem. Then we did exactly what I just described. Very manually, we took a model we used a Python package called Sentence Transformer. At the time, it was, well, it's still the go-to now if you want to do open source stuff. So you can find like embedding models, open source embedding models, because usually when Google trains these models, they release them. And others are fine-tuned. So for example, BERT was released by Google. It was big. I think it was 300 and something million parameters. Somebody distilled it. Another important concept in machine learning called knowledge distillation, and made it smaller. And then somebody fine-tuned it. They fine-tuned the small version on a data set that came from Microsoft called machine reading comprehension. So that meant that the fine-tuned model understood English. So because the data set is for that.
Mm-hmm. Well, that was the most impressive thing about large language. It seems like they understand English.
Precisely. Yeah. And they do, hey?
Yeah, they do.
Then what we did was that we said, okay, we're going to take all the questions and then put them in an index. The index will be a vector index. So traditionally today, somebody will just pip install Quadrant or something like Chroma, which is an open source vector database. But we basically built it at the time because Chroma was not there, right? And then you have this index of all the questions in the spreadsheet. Then when the user asks the question, you compute what I just said now, you project it to a vector space, you search your corpus, you return only the top K. Right? But at the time, we didn't have an LLM that we can pass the context to the question to, because there was no ChatGPT at the time, or just GPT-like models. So what was there, though, out of research, was something called Squad. Squad is it's a data set called named Stanford Question Answering Dataset. So what you can do, you can take a model and fine-tune it on Squad. And Squad will be a model that's basically trained to understand questions and answers. This is early versions of ChatGPT. So questions and answers. And the way they did it is that they were using what you call span prediction. So span prediction is more like you give the model context and then you give the model a question. The model predicts the index of the text that contains the answer to the question inside the context. Does it make sense? So the index would be like, if you have 10 words, so it will be 0 to 9. So the model will predict that from 4 to 6 is where the answer is, given this question that I'm getting. So you see how useful this is. Once we search through our index and then retrieve only the context that is relevant, we take the user's question, we pass it to a Squad model. The Squad model predicts the span of the answer. Mm-hmm. And then you have an engine that is end-to-end, where a user can ask a question and then get an exact answer to the question, not just retrieve some stuff that are useful. And I mean, I remember I gave a talk at the time to some conference called Spark NLP, and then just describing what you're doing. And then ultimately, we're using Hugging Face a lot. Ultimately, Hugging Face invited us to Microsoft Build at the time to talk about their inference and endpoints in Azure that we were trying to transition to. But the point is that when we did that, we were using out-of-the-box Microsoft technology. And this is where I say some of my views are a bit contradictory, because I'm more like, I just use the cloud, but I also understand how the cloud can be limited sometimes. Sometimes it just doesn't give you what you want.
Okay. So it was one of my questions in terms of the tools and the different clouds. Like,
yeah. It's very important to know which ones for.
What's your experience? What stuff do you like?
Okay, so let me conclude this, and then I'll tell you a few things. But so then when we did that, when we used something, Microsoft at the time, they had a tool called Q&A Maker. It was really designed for chatbots. You could deploy chatbots out of the box just by uploading an Excel file, for example. But Q&A Maker was not doing semantic search at the time. So we ultimately outperformed Q&A Maker from Microsoft with our own open source model, where we took a data set and said, for the following queries, what is your answer, right? So Q&A Maker, because it's not using semantics, it's using keywords, it struggled to handle questions like, please tell me this, when people are saying please. And what we found was that people really like saying please to chatbots, right. So then because we could handle the semantics.
I was going to say, although I know it doesn't make any difference, I would suggest be my guess, but they still kind of...
They always
say please and thank you, guys. And I just...
literally ask, are you okay? And it's like, what are you doing? We're supposed to be asking about policies to this chatbot. That's what it does. But yeah, so ultimately we deployed that stack to production in Azure, exposed it to employees. It was working. We used to call it like ODQA, open domain question answering was the technical word for it in literature in the space, and we were doing that. It was literally like manually handcrafted ChatGPT, but it worked. I mean, semantic models to squad and all of those things. But when we refactored our chatbot, once we had access to the LLMs, we got rid of 90% of the code base. So this is where the power of machine learning as APIs come from. So you see how complicated this thing was. That required my skill set and that kind of thing to build. But once we transitioned to this, I basically, it was a boring project. There's nothing I should be doing, because what you do is that now you don't need embeddings from what, you don't need squad. All you do is just you call an API. Today's rec system is like this. A user asks a question, you take the question, you ask, actually, it sort of changed, but let me just conclude this. So you ask an API, OpenAI has an embedding API, Google has it, Microsoft has it, so there is an embedding API. Embedding API is just saying, you give me text and I return its vector representations.
Okay.
Yes, because the model needs to learn how to transform the text into the vector. So when you have a good embedding model, you give high quality answers. Then you call that API. Once you get the vectors, and the vectors don't even come back as vectors, but it depends on the implementation, but they can come back as, you still need to know how to convert the vectors back to text. That's just the tricky thing. Then once you have it, you call the API again. Then you say, this is the text, this is the query. The LLM doesn't even have to find an exact match. It will paraphrase the answer. Then that's what a chatbot looks like in today's thing. But actually, it's even easier, because right now you have Chroma, you have all of these things, you have enterprise grade vector databases, and then that handle things like citation and references and stuff. Then you just have that vector database running, you feed in your documents, then a user asks a question, the vector database returns the text. Then you just take the text and the user's question and pass it to the LLM. So it's literally easy, like an intern can do this in a few hours. If you can build a rec system in 1 hour, it just means you don't know what tools to use. But it's not because of the complexity of the task. And yeah, I mean, coming back to tools,
I don't know. You'll confuse a lot of it, because as soon as vectors, I'm like, for most people locally, everybody's trying to adopt it.
Yeah.
The issue is there isn't lots of skills. There isn't a lot of people that know the stuff as well as you do. And you need to, that stuff that you're talking about, you say a Minton can do it in an hour, but once you start talking vectors, and I'm not sure.
So the way you want to think about, so let's take software. You have a very nice background in software, right?
Mm-hmm.
So if you look at software, typically it used to be difficult to build things. You needed to be like a skilled software engineer to say, let's say, build a mobile app.
Yeah.
And then we started building frameworks and stuff. All of these things are meant to be abstractions. So they abstract the complexity. So even me now, I think the last time I did memory management manually was when I was still learning C++ at school, or when I was still learning assembly.
Sure.
But now I have absolutely no idea what's happening at the memory level.
Did you learn assembly?
Yes, I did learn assembly. I did learn assembly. Wow. So at university, I did introduction to programming in C++. I did assembly. I did Java. And then everything else I taught myself. So Python. University of Limpopo, they do not introduce you to computer science with Python, because Python is a super high level language. If you learn how to code with Python, there's a lot of important coding principles that you miss. But like we said, right now, because they are so high level, these things, whether you miss it or not, you can still make an app that works. So I mean, think about it. Like right now, even for front end, there's all these web frameworks. They are abstracted away. There's like anyone can sort of like spin up a framework. I mean, even these things that I'm talking about in the AI side, there's frameworks like LangChain, there is Llama Index, that once you look at it, you can build this thing with just a framework, and then you don't know anything about what's happening in the background. So that's why it's built on top of complex mathematics, but for it to be usable and operational, it doesn't require the knowledge of the complex mathematics.
Oh, do you think it can do a good enough job? Because it's also, there's a difference in app quality. Actually, we're currently working on our own.
Yes.
And
so it depends, right? So it's like, so there are certain times, depending on what your business problem is, where the deep technical knowledge is required. Then there's certain times where it is not. So I talk about the spectrum. I like to talk about this thing I call it a spectrum. So I don't know if you remember your normal distribution. So the bell shape normal distribution.
Yeah, this sort of stuff. I know.
Yeah. So if you think about it, say for example, on the left you have people that are researchers. They're deeply technical. They know mathematics. They know physics. They know the geometry to do machine learning. To make machine learning, to come up with new machine learning algorithms, for example.
Yeah, they know the distribution.
Yeah. Then on the right, there is the pip installers. I call them the tinkerers. So these are the guys who will just do npm install, the pip install this, and build something out of the pip install. They have absolutely no idea of what the mathematics is behind the tools that they're using. These guys can build amazing things, but once you start asking them, let's say you want to know what is a complicated example I can use? Okay, for example, if it's a natural language processing model, you ask a question like, are you using back of words or are you doing semantic search? Then they're confused. What are you saying, right? But it works. They just don't know. Because like I said, there's open source tools that you can use that will work. Good enough, especially for less complicated problems. Then what we find in the market, especially when we're looking for skills and just generally in the jobs, so what you find is that certain times the deeply theoretical people do not know how to operationalize these things because they know the science, but they don't know the tools.
Yeah. Well, it's different areas of the brain. I mean, there's different personalities and skills, and kind of translating business problems into technical and DevOps is different to data science. It's like it takes different skills to actually do those jobs.
Agreed. And my worry is, why stop acquiring the skills? So it's like, for example, let's say you're a university student now, or you're some data analyst working at the bank or some firm, and then you are very good at data analysis, but you don't know machine learning. It's like, is your brain full? Why don't you learn machine learning? So do you know what I mean? So there's absolutely no reason to stop there. and this is why like, I mean, this AI engineering thing, sort of the equivalent of it in traditional software is a full stack software engineer, right?
Mm-hmm.
So a full stack software engineer knows how to build the front end, knows how to build the APIs, knows how to design the database. It's not a new concept. So in the AI world, we are saying, if you know how to build a neural net, why don't you know how to deploy it on a web application? What is the problem? So we want the full stack. We want you to be able to go from understanding business requirements, converting them into machine learning problems, building the model, debugging cluster issues with Spark, understanding GPUs. There's no reason to stop wanting to understand the next thing.
Yeah.
And also,
but that's your attitude that got you there. It's kind of, for me, I need to be a jack of all trades. That team is quite small, so say I'm this data guy, I'm the security guy. The UX guy,
Yes.
Yeah, maybe least of all UX, but
I mean, this is like, how the cloud came out, right? So, for example, if you look at, let's say, a cloud solution architect, right?
Yeah.
It's kind of a jack of all trade, but they actually know very much about all the trades. It's not a master of none. Because, for example, a solution architect should be able to understand, let's say, security from a VPC perspective and all of those things.
Mm-hmm.
Should be able to understand, like, infrastructure. Should be so it's like there's a lot of things that a solution architect needs to understand.
Mm-hmm.
Otherwise, they're not very useful because if I say I want to deploy the following workload in the cloud, I want you to help me to say, what do I need to have in place for the following stack to work? Typically, how we do it, and I haven't seen like AI solution architects yet, but I think it's a field that is very, very important. because an AI solution architect, I mean, right now we just basically have like cloud solution architects, like an AWS solution architect who, would like tell you all the components you need for you to run an API let's say you want to deploy a Spring Boot app in AWS. So they will tell you everything you need for you to be able to achieve that. From a database perspective, they know what are the different versions of RDS, and do you know what I mean? So we need something equivalent for AI, and that's where AI engineering comes in. I keep coming back to this topic because
it's also, I gotta understand it, because there are some skills. Actually, UX I'm okay with. It's just I have a lot of other people that can also do. But let's say DevOps. That's not something I started just. Yeah, I don't really want to be managing servers and that sort of stuff, but I still need to understand all of our cloud implementation, how it's set up, how it works.
Yes.
And for all these different kind of disciplines, I can't say that it's easy. It's maybe through experience I've gotten knowledge in different places, and I can kind of comprehend these concepts and eventually, figure it out, solve how to understand it enough to implement it. But I can't say that it's easy to do.
So my vision is to actually, like, even now at Standard Bank, is to build an army of AI engineers. So an army of full stack people.
How big is the team? Can you say?
Yeah, I can say, but our team is a bit complicated because, like I said, so when you start touching mobile app stuff, because that's reputation there. So there's a center of excellence that manages what workloads go on the mobile app. So they are part of our team, but they are not in the reporting structure. So this will be guys who write like Java APIs, and then like our front end, like Angular stuff.
You got me thinking whether I'm doing something wrong, but can you get AI to write Standard Bank's mobile app?
Well, you could.
It's a little bit.
Yeah, you could try. Funny thing, I'm actually learning I'm learning Next.js now. And then I've been using AI for that. There's this cool one called, so there's a company called Vessel. They released this one called V0. That's sort of optimized for front-end components. There's another one called Bolt.dev. Bolt.dev is also optimized for front-end. So like frameworks like React, React Native, and all its derivatives. So Next.js is one of them. So they're very good at that. So I can also, because I'm a programmer, I do understand. So when I'm prompting it, I do know how to ask it to change what, you know. So
I think it's really one of the best applications for the whole thing is actually getting it to learn stuff.
Yes.
From my perspective, is a base technology as a end consumer of this stuff, not as somebody that's as deeply in it as you. Is that it's really helpful tool, but you can't really replace as an expert. So it's still not good enough to write you
if
exactly what you want, and
you can build a fully functional web application with an LLM if you don't have the background currently. Some things you're gonna miss. For example, I mean, some of them especially. I mean, but Claude is getting a bit sophisticated, and even these platforms I'm talking about, like Bolt.new, it will create like a whole app directory structure for you, and then it's gonna separate them. So, for example, you will have your models sitting here, you'll have your roots, your blah blah, just like a typical setup where you separate APIs from database models. It'll do that for you,
Okay.
But like something like, maybe if you're talking
but how will you but still, in terms of, like, let's say large application, there's a element of business stuff and a lot of your business categories or things that you still need to. It's not as simple as put all the models over here and put all the roots over here and put all the views over here. There's to a large scale application, so it will still then need to understand your whole kind of business structure as well in order to get a good structure for the.
I genuinely think right now there's still limitations. I mean, I don't know if you know about Devin. There was this Devin announcement, which the guys were claiming is the first fully autonomous software engineer. So they used this thing we call agentic design, to build multiple LLM agents, right? So when you tell Devin that build me an e-commerce website, it will have different agents that deal with different components of this. There's like an agent that write unit tests, for example.
Yeah, but wouldn't it build you like a very standard e-commerce website? Maybe, as a small business, that's what you need. But let's say if you want to be a Take-A-Lot or Amazon or whoever's really in the space, your standard e-commerce website is really not good enough. Their websites are much better than that.
I think that, like I said, with the current versions that we have, yes, I don't think you can just go from a prompt to a functional production grade application. But I think we will in the future. I think we will. There's recently Anthropic released their new versions of the models, and then they came with what they call computer use. So basically, they trained this LLM to use the computer. So to know where to click, to know where to do this, to know. Actually,
I think that's all right.
Yeah, I tested it. It's really shocking. So the way I tested it, because the first thing I saw was that, Jesus Christ, this is automating testing. Quality assurance testing.
Yeah.
Remember, the manual way of doing quality assurance where you would automate with Selenium, for example, web scrapers that will click. There's a company called WorkFusion, I think, that would have provide you with these robots that can log in with username and password to a computer, click this button. It's sort of not manual, but with an LLM that constantly, because there's these things we call them self-reflection now that they're implementing into the models. Before it acts, it reflects. It self-critiques. And so the first thing I did with it was that I went to a website and I said, test my website for quality assurance. I looked at that thing, I just sat back and watched. And it was clicking every page, detecting where there's an error. And that's literally end-to-end automation of QA, I think it's...
But okay, QA documentation, I can kind of see that.
Yes.
That's
very easy.
But do you think... for sure. And it's a great tool for those, I'm sure. So you think it's going to replace developers? Do you think it's going to get that good?
So what we are seeing is that, actually, I'll say what I am seeing is that so what these models and new capabilities, especially these co-pilots, what they're doing, let's just generalize them as co-pilots. Because what they're doing is that they're getting the less complicated stuff in the workflow out of the way for you. You focus on the complex ones. And what they are impacting is junior people. So typically in a complex, imagine a complex software project. Typically we'll take the less complicated things and then give them to the less skilled programmers. And then the senior people will work on the complex things. So because now I can ask the LLM to do the less complicated things, then I don't need that junior person. And I think this is where the risk is now. So very many junior people are becoming...
But how are you ever going to be senior if you're not junior first? You can't just jump to, you need the...
That's the issue. So it's like...
How are we going to... For programming, I really believe you can't just learn it out of a book.
How are we going to absorb? How are we going to absorb these junior people when in the past, when I needed, let's say, for example, I'm one senior and then I had two juniors in my team. Then I was delegating to the juniors and then doing the complex things. Then now, if I can spend an hour with an LLM to do what I would have delegated, what is the incentive? What is the financial incentive for me to hire this person? I think that's where the risk is, and it's immediate. It's immediate because you can imagine if let's say we are a technology company that builds say software for companies. We hire a designer, we hire this, we hire that, so that we can be a complete team. If now Canva is telling me that I can literally come with a sketch, right? A sketch, and I give it, and then an LLM will design for me from the sketch. Then do I need the designer in that small team? I don't think I do, because I'm paying the designer. And if I can do it, albeit it's not going to be like it was designed by a human. Actually, sometimes...
But I want to challenge you on the whole... on the whole thing, because let's say if it replaces developers, then how long before it replaces data scientists? And if it replaces developers, then which other jobs is then it's kind of certain the machines will take us over. Eventually there won't be anybody. You can't go from junior to something. Machines are just doing everything better. there'll be like nobody left that understands this stuff. So is that the way that you foresee things going?
The way I see this, so for example, we used to need to be data scientists and mathematicians for us to do AI, right? This thing that I just described, what we're doing on the mobile app at Standard Bank, because obviously when we're predicting budget, we're using a model, then the API will consume that and surface to the customer, right? So that's a whole stack. But those things that we're doing, complicated as they are, the team, one of them is a mechanical engineer. The other one is a PhD in chemical engineering. The other one is a PhD in physics. They are doing AI stuff with no computer science background. So now one person can ask, do you see that because of this democratization of this technology, that this computer scientists who would have been the only people to get that job are not getting it now? So they're competing for the same job with a physicist. Do you see that? So what I see us doing now I think everywhere in the industry is that we're taking data scientists and making them AI engineers. And to be a data scientist, you don't need to be a computer scientist. So
the thing I can definitely agree on is that lots more people, there will be lots more jobs. As people upskill, lots more people will get involved into the fields in smaller capacities. Even like the people that you mentioned, it's a minority of people that have, because there's still engineers, chemical engineer, they're still very well educated. So it's a minority of...
Yeah. But it's just because like we're a large bank and then we have like governance and policies. So it's like in the bank in general, it's difficult to get somebody who's non-degreed because the job description would have requirements and blah, 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 But it's like the flexibility to be taking that person without a degree. It's actually like feasible. It's not difficult. I myself know people that I would hire in a bit who have no degrees. But coming back to whether we're going to replace data scientists and stuff, I think we will. I actually think so. So for example, it will start slowly, and it already is, obviously. If in the past you would have needed 10 data scientists to deliver a project, you are likely going to just need 5, each of them with a co-pilot. And also Microsoft has this co-pilot strategy, right? And I think it's scary. I don't think people panic enough about it. But we don't want to be AI doomers, they call them on the internet. That hey, there is a doomsday coming. AI is gonna. That's not.
That's what I actually also, because if it does replace data scientists, then surely it's going to replace pretty much all jobs. You're saying graphic. I still feel like there's a difference in quality. It's also like ChatGPT was the threat to journalists and developers. That's kind of so they're gonna replace it. For me, that seems very relevant. But I still kind of value the quality of the expertise in the human stuff. I don't think that ChatGPT can write an article the same as a journalist can.
So Stanford releases this paper, this report, the global AI index report every year. So the 2022's one featured gangs, generative artificial sort of, what is that? What does gangs mean again? Generative adversarial networks. So actually, generative adversarial networks were they were invented by a guy called Ian Goodfellow. He was actually drunk when he invented it. It's a very interesting story. But gangs were the early generative models, right? Because what they did is that the reason they call it adversarial is that you have this generator and then a critique of some sort. So the generator generates an image to fool the critic into thinking it's a real image. It was not generated by a machine. And the critic tells the generator that, I can see that this was generated by a machine. Mm-hmm. You repeat this process until the critic can no longer tell, right? So when the critic can't tell, then the model has won. So the early version of images that were generated by those models, it was like some black and white things and blah, blah, blah. But today, there is a website called thispersondoesnotexist.com. Mm. If you go to that website, it generates random pictures of people, completely indistinguishable from a real person. So the progress that these models are making up to where we are now, for me, it gives me the confidence that forward is the only place we can go. I mean, in literature, in the technical side, we argue about how to get there. So some people say deep learning won't get us there. Neural networks will not do that. But what we know that is going to happen is that we will get there. I mean, I don't like this AGI conversation about, hey, we're going to build a general artificial system.
But where's it going then? If it's not that, it's just then the machines are gonna eat us. What is the other one?
For me, I think that AI doesn't have to be general for it to be helpful and useful. So even a domain-specific AI, it's super useful. So if, for example, I'm using AI to accurately predict whether I should give you a home loan, why do I want it to know, to have opinions about American politics or to understand, the weather? It's not useful. It's not useful for my domain. And this is why now we have these things called small language models, where we're saying, no, guys, we don't need a big model that knows everything. We want small models that are specialists in certain tasks. And that's where agentic design is coming from. So
but that general intelligence just means it knows everything, right?
It means
usually you don't need. Eventually, the outcome is like, from what I understand of the concept, it's just going to be the oracle. Like you're basically asking human consciousness or
and
something equivalent to God. That you got to just ask question. And
people ask, how long will an AGI remain an AGI? Because remember, I mean, it could take seconds. Because remember, once the AGI is an AGI, then it means it can literally see all the human errors in its programming because it's general. And how long will it take to fix? And after it fixes it, what does it become? And this is where now
is. But then is there a threat that it's actually gonna become it's
going to become something called an ASI, which is an artificial super intelligence system.
Yeah, but it is gonna turn on us.
It depends.
It's gonna go Terminator. What's your opinion? I don't from my perspective, it doesn't seem the future, but there's lots of fear like it's gonna be Terminator one day.
Nick Bostrom, there is a guy called Nick Bostrom. He's a professor of philosophy at Oxford University. He wrote a book called Superintelligence. And in there, his premise is that these things are going to get out of control. But he gives different types of the ways they can go out of control. There is this concept called the value loading problem. It's a fascinating concept. So the value loading problem is concerned about how do we make AGI do what we want.
Okay.
There is a guy who he's very...
How do we control it?
Yeah. Because the thing is this, we don't know what he's going to want. And there is this case he makes where he gives an example of what we call it the paperclip experiment. So in the paperclip experiment, the argument is that, okay, you build an AGI system, and then the instruction you give it is to optimize a paperclip manufacturing factory. But the model, and this is what we call perverse instantiation. So perverse instantiation is when you give the model open domain instructions. So it's like, do this. When you say, I should do this, I can do it the way I want, right? It's like asking me to go to Sandton right now. I can get there in many different directions, right? And in the same time, while I go there, I can just be causing accident along the way until I get there. Do you understand? So it's a perverse instantiation. So it's like you just said optimize the paperclip. And the model, following instructions, perfects the process of manufacturing paperclips so much that it realizes that it needs to convert all the matter on Earth into paperclips. So you see, all it's doing, it's producing paperclips as instructed. Mm-hmm. But because it's an AGI, so now it converts matter into, rearrange it such that they all become paperclips. And we are matter. This is matter. Everything is matter. Then the whole universe is paperclips. But that is the issue with what we call perverse instantiation. And that's where most people would deeply think about this, worry about it, right? This guy called Eliezer Yudkowsky, he said that he came up with this concept called CEV, like coherent extrapolated volition. So the idea is that when you design this AGI system, you need to bake into the design what he calls like do what we want. So it's like
backdoors to control it.
Not really. You give it the objective function to want to do good for humanity.
Okay.
Yes. So it's like the model needs to evaluate. So they say, oh, can you do what I want you to do? And remember, now that this is intelligent than me, what I want it to do may be less intelligent, maybe an incorrect decision because I'm using my own intelligence to think that's the right thing. Mm-hmm. But because now it's more intelligent than me, realizes that's not the right thing, right? But anyway, I think that what I was saying is this. There are people that are working actively on AGI, okay, to build an all-knowing model. As a company, for example, I don't think it's useful for a bank to be worried about building AGIs, right? So for me...
How is this even possible? Anybody would love it if you could own an AGI.
Yeah. So so we cannot wait for AGI for us to do super useful things with AI. Do you understand? Because the utility of AI for us as a bank is not conditioned on it being general. And because of that, we can use AI now for very, very impactful things that with non-general models. Do you understand? So that's where the specialization comes from. So I think that when models get specialized into design, they will literally outperform designers in the generative space. Like, for example, one of the challenging areas in AI now is videos. So how do you make models understand videos? It's a difficult problem. There's not really very good video models. But the OpenAI released Sora, which is like, it can generate like a 10-second video from a prompt. And obviously, you can see that the models don't understand physics properly in the way they generate the video. Because, for example, if you understood physics, you know that how should a limb look like because you understand biology. But the models demonstrate that there's still lack of these things because you can't generate a human with no limbs. Do you know what I mean? So it's like, that's where you see the limitations of these things. But once we figure these things out, they will generate a video that it will be completely indistinguishable. I mean, today we're still laughing when we see, I don't know, Will Smith eating spaghetti, which is a video generated by a model, and it doesn't look good because the spaghetti is going all over the place. But it's like, if you think about it in 12 months periods, the next 12 months, the same video, how does it look like? The next 12 months, the same video, how does it look like? And the progress in this, I mean, you can't keep up. Like, they're releasing papers every single day. And this is the most high-paced environment in terms of innovation. And to be honest, I mean, right now we're dealing with OpenAI's O1 model, which is designed to do thinking, right? What do you think the next model from OpenAI is going to be? What do you think? And everybody's competing with everybody. Google is trying to release its own. Anthropic is trying to release its own. And it's like this race is allowing AIs to mature. And back to my argument, for me as a person working in finance using AI, I don't care about general. I just want the next best model in a certain thing, and then I can even fine tune it for my own thing.
No, sure, but they're obviously not here.
There's no general model now. There isn't general. So, I mean, the most impressive model right now, to be honest, if you stop thinking about language models, it's the AlphaZero from DeepMind. So AlphaZero is a game-playing model that can play any two-person game.
That was one of the early ones that impressed me.
That's general. I think I think AlphaZero is an AGI for games. So if we build an AGI for generating pictures, where we are saying, no, this model can generate pictures better than any other. And there is this new architecture of what they call mixture of experts. And the idea is exactly that, is that you'll have certain weights in the model that specialize in gaming. So imagine if you combine AlphaZero with some model that specializes in mathematics. Then now you have an AGI for games with an AGI for math. And I think that's how this is going to evolve. So we're going to get AGIs in different sectors, but not an AGI immediately. And once this sector is solved, we're going to go for the next sector. And then...
But then aren't you just going to combine all the models and then eventually...
And eventually we combine the model, and then there is one model that knows everything about everything. I feel like that's the most...
a model which talks to other models, but it's just one...
Definitely. Yeah. You have like a and that's how agentic design works. So in agentic design, you have an orchestrator.
I know now that you even like using other models to test your model.
Yeah.
And
And it works very well.
Working in.
It works very well. In agentic design, you have like an orchestrator. So this is the model that knows when to call which one. So there is something called Crew AI, a company called Crew AI that lists an SDK where you can actually play with building crews. They call them crews because you can have agents of agents. So for example, you can have an orchestra. So think about the way a company is built. At the top is a CEO with his directors. And each director has a specialization.
Yeah.
Under one director, there's multiple senior managers who have their own specializations. Under this senior manager, there's multiple managers who specialize in that. So all these things are agents. And the whole company is an agentic system.
Yeah, it's similar on the modern web. It's like you have one component and then there's the app and then it calls other components, which call other components. And so yeah.
So that's where I see this replacement theory coming in. Like, I mean, this Jobs, the president of Microsoft in EMEA, they were hosting Satya Nadella in India, and I watched the stream. And then he said something interesting, and I think most people say it now, but I first heard it from him, where he said that AI is not going to take your job. A person who knows how to use AI is going to take your job. And even today we know this. Like, for example, I love Copilot. I pay for Copilot, GitHub Copilot, because it has supercharged my coding, right? And I code maybe 5 times faster and better. Than when I didn't have Copilot. For example, I can generate tests automatically with Copilot. Something that used to be painful. I
was at the event yesterday, actually.
Oh yes, the Constellation event.
Yeah.
I couldn't be there. I saw some interesting statistics from the CEO there.
Yeah.
Saying that there's 660.
Is it 3? But you convinced me. I was looking at this stuff. It was for most of the geek culture crowd, it's a little bit
over their head.
Yeah.
I worry a lot.
Many people still don't even get and that stuff.
It's so depressing.
So in terms of the actual program and the presentations, but it got me worried. Unless I really get into this stuff, other people are just gonna do it way better.
Absolutely. And you know what? This is actually something I'm passionate about. Thank you for bringing this up.
Yeah.
So we, at hackathons, we used to say machine learning. This is I don't know since what year when we met. We were speaking machine learning data. I remember we used to build dashboards and all of these things. And I think it was
2017.
I was consistently worried that the other devs are not taking that approach, But I kind of felt I think that just because I'm doing data science, then I think everyone should be a data scientist, which is not right. But I'm if data is it enables you to do better things, why don't you adopt it? And my biggest worry has always been that South African developers really like being developers. They really separate this AI thing from developers. I think ChatGPT changed this a bit. But yeah, these AI things, they still think as though AI is a separate field from the software engineering that they're doing. And I think that's an incorrect way of thinking about it. I actually spoke about the Offer Zen. They released that report, that yearly report.
Okay.
And then I did comment on LinkedIn that I feel like I'm not seeing AI in this thing. It's very software engineering. But guys, we should stop making a distinction between software engineering and AI.
But look, one thing from my perspective is a progress of technology. I feel like if everybody was a dev, then the technology would be way more advanced. One of the limiting factors is in how many people actually have the skills to do it.
Mm-hmm.
So sure, maybe one day everybody will, but definitely one of the restraining factors is devs actually also learning this stuff.
And this skill thing, I think it's becoming an excuse now, because if you think about it, today you can use AI to build AI. Literally, you can start off on ChatGPT, even nothing sophisticated, and ask it, I have the following data set, I want to do sentiment analysis. You will get out there with code that can do sentiment analysis, right? But we're not even saying build a sentiment analyzer. For me, I'm not saying that. I'm saying developers. So if you are a web developer, right? You are a web developer, you are building an e-commerce website. There's no reason for you to not have AI search just because you don't understand AI. Like you were saying, there's APIs. Do you know what I mean? So the CEO of GitHub, when I looked at the numbers, he said we have 660,000 developers in South Africa active on GitHub, which is a 23% increase from last year. I mean, those are not numbers. 660,000 out of how many millions? It's 1% of the population. So we're not doing enough to get into the development space anyway. And then surprisingly, only 43% of these numbers of projects, of GitHub projects, not number of developers, but 43% of GitHub projects that come from South African developers are using some Gen AI. Right? So this means we still have this 53% of people who are developing but are just not touching Gen AI anyway. And knowing where Gen AI is today, I don't think there is any place where Gen AI isn't suitable. You're not black, so I don't know how much you know about acha, because black people in South Africa, we eat acha a lot, and I think some Durban people also. I always say to people, machine learning, and now we can just say AI to mean general. AI is like acha. You can have it with every meal. So the way we abuse acha is that if you're eating bread, you can put acha. If you're eating rice, you can put acha. If you're eating pap, anything you eat, you can put acha. So it's literally that. It's the ingredient that is universal. In manufacturing, in hospitals.
In Serbia, we call it Ivar.
Oh, okay. Is your acha like ours? I'm sure you've tasted our acha.
Huh?
Have you tasted ours?
Some of them I like Serbian.
Oh, okay. So you're still a Serbian at heart, eh? Yeah.
It's marriage. Yeah, but.
Yeah. But yeah, that's the point. The point is that this is a ubiquitous technology that you are not using it. It's not because of its complexity. It's just because of your ignorance.
Yeah, but I think you take it for granted. It's a much bigger thing in people than... It's even simple things like for me, one of the tasks is that my aim is to facilitate the culture of learning. Or actually everybody to kind of get on the same bandwagon. Yes. Your brain's not full, learn something. I know it's new, you did it like this for 15 years. But, we can improve, we can learn. There's a lot of resistance to that. There's a lot of fear that you're going to get replaced, you're going to lose your job.
Yeah.
I don't know, whatever. There's a lot of, or maybe even just insecurity that people feel like I can't do it.
Yes.
Because although you're very good at maths, for most people, from what I saw, is once you start getting stuck on some concepts, if you missed a few concepts early on, you jump a couple of steps, now it's just too hard.
Yeah.
It's you have to go kind of step by step. So I guess they at some point missed a little bit, and then it just gets too hard, and now it just feels like it's too hard, I can never do it. Many people feel that way. They feel like they can't ever do maths.
So the thing is, I agree with you, and I also disagree, right? The agreement is there is a level of mathematics that you need to know depending on what type of machine learning you're doing. So, for example, let's say you work at Lelapa AI. I'm not sure if you know about that AI startup called Lelapa in South Africa. So if you work there, for example, you are typically doing, I hope, fundamental research. So, for example, how do we build LLMs for Africa? Because ChatGPT is great, but it's really not it tries to speak Tswana and other languages, but you can see that something is not happening there. Mm-hmm. So if you're a maybe you're concerned about building, that. Then what kind of people are you going to hire, right? You can't just hire pip installers there, because they will need to tinker with the model architectures and, then okay. But if you are trying to productize this thing, then all your let's say you have Swift engineers and other people and building a mobile app. If you want to do on-device machine learning, all they need to know is to say, how do I load up a pre-trained model to do a following task with Swift code? Do you know what I mean? And in that way, what the embeddings, what the weights, what inside the model are, it's none of their business. They actually, it's like using a Google API. You have no idea what Google is doing, but you just know that the results are helpful to you. So that's where my position is. It's these things can get difficult, but no, just because you're a software engineer does not mean you should not embrace AI because you don't have an AI background. Yes.
But kind of in a similar sense for many people, even just like, I don't know, matric maths is difficult. I don't know, especially university maths is difficult. That's kind of what.
Yes. But yeah, so I think, for me, and to be honest, I'm always having this argument with people. Like, yes, I know you're doing Java. I know you built Java APIs, but you can do machine learning in Java. So, do you know what I mean? These things are just, they're tools now. They're tools. We should use them. And I worry a lot. I saw that South Africa, they released an AI governance framework. I tried to read that document, but yeah, it's great. It's a good, it's a step in the right direction. And I mean, if you look at the people that they were consulting there, I mean, Professor Marwala, the former VC of UJ, was one of their people there. So like really serious minds applied themselves there. But I feel like it's less prescriptive. It's like it's a general view. I feel like we need to have an opinionated framework, where we literally say this. Like, for example, there is a cloud sort of regulatory framework from the SAB that governs what banks can do in the cloud. And it's quite prescriptive, you know. It can tell you, it addresses cross-border data transfer issues. It addresses PII, PCI. It talks about encryption. So, for example, in the bank, if you want to do a cloud migration, a workload, you need to first talk about what you call information types. Understand what the regulator says about which type of information, right? You can't just migrate anything. You have to migrate the right things under the regulatory framework. But the framework allows you to do it. So, for example, I actually don't know what the AI governance framework of the country right now says about.
Is it framework or standards? It's kind of.
I think it was titled framework.
With financial, it would be legally prescribed, I'm sure.
Yes, it is.
There must be some rules.
So it's like, if I wanted to deploy Gen AI to my customers, what are the rules, you know? And because of this, I mean, our CEO said this when he was announcing the financial results, that we are going to be fast followers at Standard Bank, but we don't want to be leaders. Obviously, that depresses somebody like me, but you understand why. You know, you understand why. Because me, I want to innovate. Like, can we do it first? But you don't want to do something like this first.
No, somebody has to innovate. Look, it's in tech. You don't want to be. You want to be kind of leading edge, but not bleeding edge. You don't always want to upgrade because the new stuff is sometimes buggy. There's a lot of risk to actually.
There's a lot of risk.
Kind of.
I mean,
I also like to try to keep up with it now and get there, but it's also. There's an element, like if I'm 6 months, a year behind on the stable version, you need to be on the stable version, not always on the latest. It's riskier.
So my understanding of being a fast follower is that you build the stuff, but you don't release them. Then once releasing them becomes a thing, you're not starting from scratch. You just release what you have because you've been working on it anyway. What would be a problem for a fast follower would be if you stop and say, we are not doing it until the first people do it, and then we'll follow them. That's sort of what caught Google off guard with ChatGPT, because I'm sure you'd remember that it took them time to release Gemini after OpenAI released ChatGPT. And OpenAI used their technology. Google invented the transformer. So they were using Google technology to build a product that Google never conceptualized. So when that happened, Google was like, snapping out of it, say, let's build our equivalent. But I feel like if Google had been building a ChatGPT-like system internally and not releasing it, and then OpenAI was, because I'm a private company, I'm not scrutinized like Google as a public company, I can release and disrupt the market, then Google will be like, okay, you released, observe the regulatory framework and say, we are coming. But they really had to like up their game, because like they're like, oh my God, So.
But I think from a business perspective, I think in terms of tech, there's so They didn't start developing the tech there. They did take some time to release the Gemini, but they obviously had.
Yeah, they've been training deep neural networks for a long time. I mean, they were some of the first.
So it's kind of packaging it into a product. OpenAI kind of did package all these large language models and said, hey, this is what it can do.
They had a product idea.
Yeah.
They had a product idea, and then they just used the existing technology. But yeah, so I think we are fast followers. So but what I mean, I'm contending with Gen AI right now in the bank with multiple projects, right? And most projects are sort of like POCs and all of that kind of thing. The risky thing is customer facing workloads, because Gen AI is it's not controllable. The hallucinations are bad, and all of those things. So even regulatory speaking, as a bank would be nervous that we're a financial service, so the regulator. So I would we should get to like a point where, because like for example, when you are interacting with AI, you can feel that you're talking to an AI, you're interacting with the AI. So for example, when you're doing image search on an iPhone, when you're doing image search on Google, you can see that there's something clever that's returning these results. Like let's say semantic image search, where I can say photos of Mabu at the beach, and then I get all beach photos of me, right? So that's an advanced use of AI by the customer. I mean, Google got in trouble with their Google Photos thing for just that. What they did was that when they released the app, they had a model that would group photos into folders. So like party photos, blah blah blah. Yeah, and then it built a folder called Gorilla, and then put all the black people in there. So then they had to roll back and then try to fix that model. So this is the risk of sort of advanced use of AI in customer-facing situations. You see, so we need to get to a place where I know, for example, that if I'm talking to my business manager and then he's saying, or a product owner who's saying, "Can we integrate AI in this product?" Regulatory speaking, what am I allowed to do? So that's
obviously, if you don't understand it, and even like in terms of that AGI there's a lot of fear if you don't understand it, and people generally fear things we don't understand. There's also kind of with cultural differences. It's the primary thing is there's an element of fear of things you don't understand.
I read an interesting report from Slack, the Salesforce owned company. So they did a survey of a couple of people. I don't remember the exact number, and then it was found that employees actually don't disclose their use of Gen AI to their employers. Because they have fear that they will say they will look incompetent. It's like they need help. So why are they using AI and stuff?
Yeah,
I found that to be interesting. It's like, I mean, how do you feel? You're a CEO, so what's your view on employees like using AI proper, integrating it in their workflows?
To me, it's a lot more understandable because I feel like I can somewhat understand these people. Although I'm not very much like that. At least I know, like, sort of driving change management or I can see sort of resistance to change and fears, and then I work through just sort of, we're not after you. Yeah. We still love you.
Yeah.
But I can understand kind of the people and where they're coming from.
Yeah.
So I don't think it's strange at all.
So one of the interesting things that happened after ChatGPT was that also, obviously, like most companies were really like saying employees should not use it. I mean, there was a time where it was a global thing where like big companies across the globe are saying people should.
Yeah, kind of like the universities. I don't know.
Yeah.
Official stance was.
The universities is an interesting case. I actually wonder what will education look like in the next 10 years. It's very fascinating. But yeah, so it's like because companies were saying don't use it, what. I remember having a conversation with a colleague about this, that if we don't find a way as a company to enable employees to use Gen AI in a safe way, then they will use it illegally. So for example, if you say don't put bank data in ChatGPT, but you don't have a ChatGPT-like system that can take bank data internally, then they will cheat and then put it in ChatGPT and then not disclose.
You know model poisoning, I'm sure you know.
Yes, I do. It's a big risk. I mean, it's just it's just it just shows that there is something fundamentally wrong with deep learning, and especially because model poisoning, or what we call adversarial attacks, all models are prone to it. I mean, there is a new concept on Reddit that's always trending, where they're jailbreaking the models. So once OpenAI releases a new version, they jailbreak it to make it say things that it was made not to say.
Yeah.
But they're all susceptible to the same hacks. So, I mean, people say, like I said, that there's a lot of people who don't believe that we're building intelligence here, because we know that, the one intelligence system that nature has built is humans. We're more intelligent than most things. Some things are more intelligent in specialized areas, but we're general. But we're not back propagating.
Hard to argue that, yeah.
We're not back propagating gradients, Like, there's no gradient descent in our learning algorithms. And then we're out here back propagating gradients and saying we're building intelligence. It's like, we know that we are all mathematics, but is that how math builds knowledge? We don't think so. And we're definitely not. So, for example,
But, okay, one thing that's very interesting to me is, like, for one, maths is like our best understanding of the universe, and lots of things, it is very mathematical. It's almost like it was built on these simple bytes, the way that binary becomes all the things on the computers.
Yeah.
From very simple things that kind of multiply and...
Yeah. And yeah, we as humans, we have been very good at harnessing the nature of nature for our advantage, right?
Well, we're trying to learn it, and there's more we can learn about nature and how actually,
and then we use it.
Reality works, then we kind of apply it to...
Like quantum mechanics gave us like microchips, for example.
Well, most of scientific progress is actually... So you don't discover it, you don't invent it, you discover it, yeah.
Oh yes. It's all discoveries, because nature is written in mathematics. But yeah, I think that, Demis Hassabis, when he started DeepMind, his vision was that he has a PhD in neuroscience. His vision was to take algorithms of nature that are being implemented in our brain and then computerize them, right? So it's like, how do we look at what the hippocampus is doing and then try to program a hippocampus? This guy called Jeff Hawkins, he was the CEO of a company called Numenta. Jeff Hawkins actually invented the touch. There were these things called Palm Pilots. I don't know if you remember. Before phones, there were Palm Pilots. He invented that, and then he stopped doing like tech stuff, and then took all the money that he made from the company and started a research lab called Numenta. And their goal was simple: produce the brain in a mathematical way. He came up with interesting concepts. Fascinating. I just recently read his book. Called the first book, it was called On Intelligence, and it was just explaining how the neurons work. And then the second book is literally like describing some of the experiments that they did. And the fundamental thing is this with the brain is that...
What are the learnings? Because that seems too much of a stretch to fully understand. I don't think as humanity we're there.
So
I personally don't think we're anywhere close to understanding our true nature and the nature of the universe. I feel like there's so much that we don't know that it far outweighs the stuff that we do know.
One thing that I find fascinating recently in AI that's happening is AI for scientific discoveries. So the reason why Demis Hassabis actually won a Nobel Prize was because he led the work on what they call AlphaFold. So he won a prize in chemistry. Computer scientist won a Nobel Prize in chemistry. Even a computer scientist in the Jeff Hinton, the part of the godfathers of AI, he got a Nobel Prize in physics, because of like how they used physics models to build the early versions of neural networks, like these things called Boltzmann machines, and they were using like energy like from physics. So that discovery warranted him a Nobel Prize in physics coming from machine learning.
Yeah, but obviously also prime example is like deep learning in the neural. It's designed and
yes,
it's trying to replicate what we kind of learning, figuring out how the brain actually is.
Yeah. But you see, Demis Hassabis, the reason was that AlphaFold basically technically solved the protein folding problem. it sounds silly to say this, like we take it for granted that we can sit here and say that AI was used to solve the protein folding problem. Because this is a very, very big problem. It's a very difficult problem. It's like protein folding deals with like how do you predict protein structures from their nucleotide. No one could do this. Like in the past, it took like a PhD to come up with one, So, but then now we have an AI that predicted almost all proteins.
Okay, so it's this on the molecular level of the proteins.
So this new obsession with using AI for novel fundamental scientific discoveries, it's important. I think once we get like the ChatGPT of these scientific fields, in a way that, do you see how ChatGPT is useful? It's a language model, but it works, So it's like if we get models that work in these individual scientific fields, then they can help us understand the nature of reality. Because we can't model all quantum particles right now, right? We can't get to the particle energies we want. But if AI can help and say, no, don't do it that way. Maybe the Large Hadron Collider is the wrong approach. Maybe we shouldn't be accelerating particles closer to the speed of light for them to tell us what they are individually made up of. Maybe we should be doing something else.
Sure.
Yeah.
I don't know if you gave a straight answer on what's going to happen, are they going to eat us or not? So
yeah.
Maybe the bigger risk is if it gets into control of malicious hands. That's generally the stuff with technology. You can use it for progress, but it's also every technology you can also use to screw people over.
Yeah.
It's a just to advance yourself.
Can defend yourself or it can attack.
For now, I like to think that it is the tool for us to learn and to do things better, and that it's a tool that's going to facilitate this learning process even more than the internet has, which is,
So, you know what?
Obviously change things.
I agree. So the way I like to think about this is that existential crisis, as in like the existence of humans, is at risk because of AI. It's a far-fetched ideology, but it doesn't have the probability of zero. But there's more immediate risks that we need to talk about that are more important. And like I go back to this. If I work at a bank, I'm not really worried about the risk of AI taking over the world.
No, I agree with you. I'm asking you just for your opinion, because you know the stuff very well. So
yeah.
I'm actually
so there's more risk. So okay,
for the average person, that's kind of the first thing.
So there's long-term risk and short-term risk. Long-term risk is what I just said: perverse instantiation, or we don't know, man. Like these machines. If we lose control, we don't know how we would control them. Because there's this analogy where we use to say humans are intelligent, right? We want to build a road and then we find ants on the road. We kill all of them. But we're not really trying to kill ants. Like there's no one who's like trying to kill ants. Just that the end is in my way. I want to build a road. So an AGI, we could be ants. We could be like, we're just in the way, but it's just trying to achieve something. And then we're just a byproduct of it.
There's lots of scientific sci-fi concepts and movies and whatever.
We're just byproduct. So there's, when you want to think about the themes of the risk, it's like that. But right now, as a bank, I'm really concerned about phishing, right? Today, voice cloning, it's an open source technology. So if somebody clones your voice and then calls your wife with that voice and say, I'm going to send you an SMS. Do you know what I mean? What are we going to do? Like,
people are saying, like, they call you, I got your kid. Your kid is saying,
exactly.
Send the money, I'm in danger.
So these are immediate risks of AI. And they're financial, by the way. Because, there was a bank, I think it was I don't remember. I think it wasn't Japan. It was somewhere there where this finance person got on a meeting with a senior executives. And then they asked her to approve a transaction or initiate a transaction of millions of dollars or something. And all those people in the meeting, they were generated. So by the time the transaction was done, they realized that the meeting was fake.
Yeah, I remember the story that there was a big...
So you see, this is like immediate risks. And it's an interesting question. I had a conversation in the bank with the senior executive who is in the fraud risk management space that actually, what should we do? Where are we going to take the technology to know that the people in the meeting are correct? It's a fascinating concept. I'm on Teams. I use it all the time. I'm with my colleague. He's here. He's talking like them. And what should I do? And I think his view was that like Microsoft needs to, like Microsoft and other companies that give us this platform, they need to deploy the technology to teams to be able to do real-time deepfake detection. Because me as a bank, how can I do deepfake detection of a meeting? I don't own the stake in Teams. I don't have integration in Teams that I can say interrupt the call during when. Do you know what I mean? So it's like at the end of the day, we need to be protected by the very people who are providing these technologies to be able to minimize this risk. But this is a huge short-term risk, and then it's better to worry about that than to worry about robots and other things.
No, I agree with you.
Yeah, but other people should be worrying about it.
Yeah.
There should be philosophers who are dealing with this.
Well, the people that are actually making the stuff, they obviously need to be worrying.
They worry about it. Yeah, I mean, I was watching the Lex Friedman interview of Dario Amodei recently, and the approach that they are taking.
I've also had quite a lot
at
of
Anthropic. Yeah,
there.
yes. It's very, very nice to fundamentally worry about security and safety before you worry about productization and commercialization. But for me, as a user of AI, I want to make the buck for the bank. I'm not too much worried about whether the language models are gonna take over the world.
No.
Yeah,
sure.
And then I wanted to ask you,
Yeah.
Have you had any AI use cases internally in at ITWeb? Like, what are some of the AI stuff that you're doing?
That I've implemented or that I'm planning?
Perhaps you deployed or you're thinking about.
The only one really is the search that we've deployed that I've been thinking about. There's lots of things I can do for publishing. I have a custom publishing PMS. It's reasonably trivial for me to just add the ChatGPT stuff or the Gemini stuff into it to help with those things. In terms of organizing all the content and kind of the people, the categories, those sort of things, it could help us. That's one of the kind of, for 15 years, even my dad was working on this problem, like in all the text, what is it?
Yes.
The main topics and what are those topics?
Yes.
If we knew that stuff, we could, gear up, make more useful pages with information about these topics. Obviously recommendations of which articles you want to read and suggestions.
Yes. Okay, that makes sense. I mean, it's actually quite funny because your field, like journalism in general, was one of the ones that was sort of expected to be disrupted significantly by like ChatGPT like models,
Yeah.
I'm keen to know, do you think that we can get to an AI maturity where you just tell it, write about this, and then some agents go and search what's the latest? Because, that's what your employees do now. If they are writing an article, they do Google searches, they read stuff, they do this. Why can't an agentic system go read these things and then come back and write an article?
I don't know. If it gets to the point that it can see and hear everything and it can report new things. In terms of creativity, it's also one of the common perceptions was that these models aren't as smart as the initial hype was from like just the industry. So for like, let's say news, AI does not know what happened. It can't actually come up with anything that's new. It can combine ideas. It becomes new by like kind of combining. And I guess maybe in that sense, that is kind of like how the human creativity works. Maybe, I don't know. But I still feel there's something that is not really new. In terms of news, it's very specific. It would need to know, like, these things happened. You can sort of maybe just say, these things happened and write me a report, but still try to be objective, see to get different sides of the story and those sort of things. It would need to know basically everything to report the news. It would need to hear everything, see everything, and then tell you, well, this is actually what happened.
I see.
You still need somebody. But even in terms of creativity and those things, maybe we can foresee that there will be one day where it can replace designers and developers. I really don't think even the tools are amazing. The technology is amazing. But for me, there's a in testing it with code, there's a lot of stuff it doesn't know. If I'm learning something new, if I, like, say, want to really get up to scratch with Python, that's probably one of the first places I'd look and then say, how do I do this? Give me these common things. But
yeah,
there's, at least in terms of code, there's nuances and technicalities, and there's lots of stuff that I can't explain well, but I can see that it's not the same.
yeah,
And I don't know whether my opinion is that no, it's not replacing writers and developers. It's actually just, there's more content creators. It's the best tool for them. And there's just going to be more journalists and content creators, and there's just going to be more developers. And these are just tools which are enabling us to do that.
yes. Are you familiar with an app called Perplexity? Perplexity, it's a search engine. Basically, they're well, the CEO says they're not competing with Google, but basically it's a Google replacement type of thing. So, yeah, I think it's an agentic system where you ask about the topic. Well, you actually ask a question. I mean, Google can do this to some level, but it's not as great as Perplexity. But you basically do that, and then it unleashes like a bunch of researchers in the background who takes your topic, look up the stuff, and then come back, and then have a summarizer, and then it answers the question. So I just feel like, especially for research, I mean, if you think about maybe a company like LexisNexis that are empowering lawyers with this, building a case and stuff, I feel like that's like proper use cases of agentic systems. So I think over time, I mean, you're right, these things are tools, but my worry is that the tools, because they're augmenting these humans, they make other humans redundant. So it's like if you have a team of 5, now you can do the same job with a team.
I wouldn't say redundant. I would say efficient.
But efficiency.
But then there's always like new things to do. Like if you look at just from the history of tech, most of the jobs, they didn't exist before. So also with the tech revolution, that created a lot of jobs.
Don't you think that when companies become more efficient, they hire less people?
Sometimes. Look, the idea is that it'll take us away and we can just be creative, right? That's a nice way to think about it. That it can just do all for me also, if it's trivial stuff that really easily can be automated, it's not a purposeful job for a human person. They're just doing that for a job. It's not something that they really is a passion they should be doing with their life.
But most jobs are like that, and we empower. So that's one of the things that I worry about. And I basically, when I look at the infrastructure, the tech stack at Standard Bank and everything, it's like this is very possible to do. That's like call center operations. So most companies spend a lot of money on call center operations, and call center operations are typically not. It's a cost function. It's an enabling technology. So if you have agents who have to call people to try to sell them something, and then you have agents who have to listen to calls when customers are calling to complain about something and stuff like that. If you think about that,
I need to get an agent to battle these bots. And also I heard there's like some answering agents now that will sort of filter.
And even now the calls that come in, you can tell that this is not a person.
And then I get called by robots, and it's even more annoying.
Yeah. But it's acting like it understands you. May I continue? And I'm like, this is not a person. But yeah, so you see, so for example, I grappled with this with one of my previous managers when I was teasing that automating call center operations is a very beautiful use case for AI, but it's not. And also, this is the problem: is that companies need to also be ethical about the deployment of AI. So it's like, just because I can do it, it doesn't mean I should. So, for example, if I said that I can deploy this architecture that can reduce our call center operations by 90%, because instead of needing 1,000 operators, we need 500 with co-pilots. And then does that, because remember, I mean, companies do this all the time, especially American companies. I mean, when Tesla became efficient, they cut the workforce by 10%, you know? So it's like, then now when you're cutting your call center staff by 10% or...
Elon Musk said that when he took over, he got rid of 80% of the people.
Well,
Not directly, some of them left, but they're down to 20% of the staff.
now he's going after government employees, right? With the Department of Government Efficiency.
Yeah.
But Elon Musk is an interesting character. But anyway, if you can do it, should you? What I worry is that there is, and you know, AI is very impressive in India. There's a, you know, in India, we sort of, the world use India for many things, right? So like Amazon with mechanical tech, it will use like a bunch of Indians to label images. Other companies, you know, like even for software engineering, most of contractors in companies you will find, you know, and as AI matures in a place like India. So for example, when you write like Microsoft certifications or AWS certifications, you'll be like invigilated by some person in India. So the big companies, especially American companies, use India for many things. So a country like India, where most of the jobs come from things that can be easily automated, what will happen is that, although, let's say for us as a responsible bank, we're like, no, we're not going to automate our call center operations. That's a crazy idea. We have people that we care about. An American company will come with a software that does it. And because not all companies are the same, not all companies have ethical standards, that disruption will happen whether we like it or not.
No, the execs will make that call. It's also, from my perspective, we're very small, but I'm sure if we were as big as Standard Bank, there's no chance. At the end, you have to look profits, blah, blah.
Yes.
If this is efficient, it's going to make me lots of money. You know, that's eventually what they're going to...
So I advocate for
They almost don't have a choice.
Yes, I advocate for the deployment of AI. I am that guy, but I also think that people must take time to internalize and think about the risks and the ethical principles of that deployment. Just because you can do it doesn't mean you should. I think sometimes you need to take a step back. Sometimes you need to, think about the impact of the stuff. So I like your analogy that over time we'll just be like super efficient people, and I agree. But I'm saying, as we become super efficient, jobs are not going to be available for many periods. They are not going to be. I mean, you can think about engineering, like building cars and...
But what are the different skills? What are the kids that are going to grow up with these things? That's also one of the first real big impressions from ChatGPT when I saw it. And I was testing with my daughter, tell me this fairy tale about blah, blah, and blah, blah. And it was right out the whole story. And very cool for her to play and stuff, but just kind of thinking as a tutor, even to children, to explain. Now, growing up, you know, we kind of grew up with internet, and now it's different than the people that didn't.
Yeah,
there's kind of divide. The children that are going to come, I don't know what kind of people they're going to be. They're going to be far.
Yes.
You know.
You know, that's an important question. One of the things I don't like about South Africa is that we're always late. Like, for example, you know how the rest of Africa, once they had access to the internet, they really understood what monetization is. So we took time to start making money on the internet, you know. We took time, but if you look at, like, I mean, most of African unicorns will come out of Nigeria, will come out of, like, you know, other African countries, but not South Africa that much. I mean, I don't think we have a unicorn in dollars in South Africa, but I know that...
no, we have. I think it's overlooked. I mean, in lots of ways, South African tech is really world class. Obviously, banking is the first example.
Yeah. No, that's true. But what I'm saying is that how a technology cascade in the general masses. So it's like, so if you look at what the internet did to Nigeria, or what the internet did to Kenya, like, people pivoted very quickly into harnessing the power of the internet. So with AI, it's the same thing. We need to pivot very quickly into harnessing. I mean, what we were saying about, for example, the geek culture type of crowd with
to kind of really adopt it in.
Exactly. So we need to pivot. We need to pivot because this is a massively powerful. And the other thing, I mean, you're asking about kids. My nephew, it's the matric. So I've been helping him the whole year to apply for university. And every now and then I keep asking him, I don't actually know if this is the right thing to do. Like, to study this, it's like you want to study it for the next 3 years. What will the world look like by the time you complete? But it's like, I really don't know.
But the main point of school is that you learn to learn. But it's kind of, maybe you take that aspect for granted, because I'm sure somewhere in the history you got something happened right that you kind of started this whole trajectory of learning. But from what I understand of school, the most important part is not really what you're going to learn, that you learn the practice of reading and learning, and that's what you learn.
Yeah. I mean, that's all we can do at this point. You just have to learn, because you don't know what's going to be irrelevant when. But I mean, I think it was even Jeff Hinton, the guy who won the Nobel Prize, he predicted some few years ago that radiology will be completely automated because of how convolutional neural networks, to be specific, could understand images. So he thought that medical imaging will be a complete technology that is completely outsourced to AI. But today we still have radiologists, So sometimes we also hype it, we over dramatize what it could be. But yeah, I do worry that I'm increasingly having less advice for what kids should study at school for them to make themselves future proof.
Yeah, and that in terms of subject matter, 100% agree. But it's also, I think the value is that you get the habits, that you get
yes.
It's kind of, for me, I was lucky. My mom was very strict. I hated it at the time, but she forced me to read and do my homework. She was very, and sometimes I look at the window and kids are playing, and I'm like, I try this book off by heart, But it's kind of, then later on in life, I'm like, that's the good habit that actually right now it serves me well, because I developed.
Yeah, and such things you never lose. Hey, it was Einstein, I think, who said, "What's the difference between education and something?" And then he said, the other one, education is that you never lose it. So it's like, once you are really education and knowledge is that knowledge you don't lose, but education you can. If you learned the fundamentals of mathematics at school, regardless of how old you grow, you will always have that appreciation of fundamental mathematics. It's like that thing you don't forget.
Yeah, well, that's knowledge and way learning and stuff. You can never take it away, whatever it is. It's even like for people, even if you don't like your job, at least learn and do it for yourself. Because even if you don't get paid for it, you keep the knowledge, and in the future it'll serve you. Okay, and then let me ask you another. I agree it's not practical, but just sort of philosophical question on, like, if kind of the Matrix question, if the food tastes real and everything feels real, and if these deep fakes and everything, the robots are going to be real, and you can't distinguish that it's not real, then does it really matter?
Yeah.
That it's not real?
Well, it's so scary, eh? It's very scary because actually it's funny because I was just having a conversation with a colleague who recently bought a PlayStation. So he said he hasn't done PlayStation since like university. So he wasn't really aware of how advanced gaming has become. So he was shocked by the graphics.
Mm-hmm.
Obviously, also the tools, like, the fact that the console, the controller is vibrating, doing these things. But most importantly, the graphics. And it's like
how immersive it gets, yeah.
Yes. And even with VR now, I think it's not gonna. I mean, and with deepfakes now, I think in a philosophical way, where they say that the universe is a holograph, so basically we're just being simulated. Once we simulate the physical world in the way that is not indistinguishable, how would we know that we are not a simulation? So, I mean, you give it, and I like these philosophical things. I read a book called the Magic of Reality. I mean, the fabric of reality, I think.
Sure. And this is a fascinating topic. I'd love if we can talk about this.
Yeah. It's shocking. I mean, this guy had they call it the multiverse theory, right? But it was expressed in a way that I haven't heard it before I read the book. I always knew about the multiverse. That, so for example, when you come across a binary decision that you have to make, or maybe let's just say when you collapse the wave function, they speak like this in quantum mechanics, that by the time you make an observation to a quantum or to anything that has a quantum property, you need to collapse the wave function, because before you measured it,
if you observe it, it's a different outcome.
Yeah, it exists in multiple different states. So his argument was that, like, we every time we measure and collapse the wave function, and we think the ultimate outcome of that process is what we observed, it's not true. Actually, the other possible ultimate outcomes still happen, but they just happen in different universes. So in every other universe, that outcome happened.
Mm-hmm.
And I'm like, what? So if you turn left, you turn right somewhere else. And then
I've thought about that. Like, is there like another me that's suffering now if I'm doing well, or if I'm suffering here, is there some other me
who's healthier? It's interesting. It's like it all zeroes itself out. It averages out. So at the end of the day, you came out a better person because all versions of yourself experienced everything. But
one thing I want to tell you is, like, when you bring up the games and stuff, and it's not, I'm still an Orthodox Christian and those things, but in terms of like nature and reality, like, I've played games my whole life, so once you're into it, your kind of consciousness goes there, even when it's bad graphics. You know, you feel like you're there for that time that you really engage with the game. You actually feel like you're inside the game.
Yes.
And kind of seeing, you know, graphics going, it's very, you can see clearly, well, actually, this is going to become looking real soon. And, you know, then when I'm playing the game, then it's going to start feeling very real.
Yes.
Even more immersive and engaging. So how far away is it to be just different from reality, and what is there a possibility that maybe nature of reality is actually like that?
So one of the world's greatest innovator and programmer in the form of Mark Zuckerberg literally changed his company to focus on the metaverse, which is this giant simulation. So he's investing hardware, he's investing billions. He's spending like roughly $10 billion a year.
I know it's quite popular even in the tech. There's lots of the game theory and simulation theory, but
if you think about it, I mean,
from my perspective, and even like a while back.
So if when these entrepreneurs take what we call philosophical physics questions and make them products, do you see the problem? Because if you say, how much of a simulation can you build for me to be unable to tell the difference? And then they are actively trying to build it. You know, it's like, I don't know if you know the movie called Ready Player One. It's like, I feel like at some point the simulation will feel more real than reality. And remember, in the simulation, you can do many things in the simulation. The reason why I suspect somebody would want to spend 24 hours in a simulation is the amount of control. You know, remember, in a simulation, you are a quantum particle. You can just pop up here and pop up there. So, you know, that amount of flexibility and
of course, life is better in the simulation. You know why people play games? I mean, there's not anything unreal for people to play games all weekend long, and sometimes not even sleep, or minimal sleep, you know, if they're racing or something. And, you know, they kind of feel like they live there, like a basic concept of, like, let's say, microtransactions to put your character. Which, from one perspective, it's very hard to understand. Why would you spend money on, and this amount of money on, you know, a graphics for your icon? But then from a gamer perspective, I can understand it, because if I spend a lot of time in this game and this character is me, and I'm interacting with other people's characters, then I want my character to have the nice clothes and to look good. I'm communicating, I'm engaging with other digital beings, or So it's the same reason why I would want to buy nice clothes.
Yes. Yes. No, that's true. I mean, and it's getting crazy. There is a guy who, Palmalaki, I think. I think his name is called Palmalaki. He's the founder of Oculus. Oculus was actually acquired by Facebook, and then they made it this headset that they are making now. But the initial guys who invented that headset is this guy called Palmalaki, whose company was bought by that. He made one headset where you are in a shooting game, and then the headset is equipped with a weapon on it. If they shoot you in the game, you die in real life. And then he said that, you do have this now, even with VR games, where you wear this suit, and if I kick you or if I punch you, you feel the punch here, right? They simulate the pain for you. But he made one where you die. Like the headset is lethal. Like if you put it on and then you get in that game, you're going to die if they shoot you or if something goes wrong.
Yeah.
But it's like, that's how crazy it is, right? And I think
who would want to play this game? Why wouldn't you just go shoot it?
I don't know, but it's just like, but he's a crazy guy. I mean, right now he's actively working with the military to create them like advanced drones and that kind of thing. He literally believes in the like military industrial complex that the United States should not.
Well, the biggest risk with all this stuff is actually some people, they're crazy actually using this stuff to. That's the really much bigger risk, the real risk in terms of potential risk for humanity than actually of getting out of control. My guess is actually maybe we'll actually just learn more about ourselves and who we really are if it helps us figure out the universe, whether it's like us or not, because there's also lots of things about our own body are very seem kind of like a biomechanical device.
Yeah.
Like a basic question, why does everything need to sleep? Like everything needs to recharge the battery.
Yes.
It's like literally go get plugged in and recharge some sort of battery.
Yes. And apparently like sleep is the thing that like, so like during sleep, that's where we store memories that, we replay the whole day in different types of ways until.
I think we still don't understand what really happens in the state.
Yeah.
It's basically, I think every kind of creature that needs to do it.
We don't. I remember when I was in university, I had a friend who stayed with me who was studying psychology. Yeah. Then I would read his psychology book. So I read The Interpretation of Dreams by Sigmund Freud and other things. So it was super interesting, just because remember we are chemical things. We are physiotherapeutic things, and then we're still psychological things. So when you enter the psychology world, things start becoming even worse, just in terms of how we don't understand ourselves. Because from a chemistry perspective, we kind of have a clue. For example, we understand why people get high. It's like like this CBD or THC thing. It's a neurotransmitter, whatever. We can have some explanations, but the psychological things that we have absolutely no idea. I mean, I don't know if there's a book, Thinking Fast and Slow. They talk about like system 1 and system 2 and blah, blah, blah. And then they talk about a bunch of experiments. And it's like, so one of the things, I just want to focus on like the neuroscience a bit, in terms of the psychology of who we are, because we don't understand ourselves. So for example, we we understand how much how long your eyes must look at an object for it to be conscious of it, for your mind to be conscious of it, right? So by the time you say, I'm conscious of something, it must have stayed in your vision for certain milliseconds. But if you show people something under those milliseconds, they will never be aware that they saw it. There is something interesting called the gorilla experiment. You can watch it on YouTube, where the experimenter asked 2 teams to play basketball. Then the subjects of the experiments are asked, count how many times the blue team passed the ball. Then you are there counting the ball. And then a massive gorilla passes through the people.
Mm.
And you have absolutely no idea. You haven't seen a gorilla. After that gorilla passes, the experimenter is like, did you see the gorilla? What was the color of that gorilla? It's like, what gorilla? Are you crazy? There was no gorilla here. And there is literally a giant gorilla passing through. And this person does not see it. And this is what we call conscious attention in neuroscience. It's like the brain is not aware. It's ignoring everything if it's not attending to it.
Mm-hmm.
And then it's like, how does that work? You know?
Well, it's even they say for what in multitasking, people that are good at multitasking or the brain, nobody's brain actually multitasks.
It is a serial processor.
It works like a thing. It's just jumping from task to task, executing one and the other, and
focusing on this and this and that, but never.
But it seems like your brain, like a CPU, can at a specific time do only one.
Yeah.
Preparation. Kind of like what is time and what to a CPU is just CPU clocks.
But you see, that's interesting because the brain is massively parallel, right? It's super parallel. Like the brain, all the neurons, you know what I mean? Like, but so it parallelizes the execution of a serial job. So only once in the this experimenter, this neuroscientist guy, I forgot his name. He wrote a book called Consciousness and the Brain. I read that book and I was like basically bamboozled by how powerful the brain is. So if you show one eye an image of something and then show the other eye an image of something, what will the brain see? So in the experiments, they knew what the other image, what region of the brain it should trigger and what region of the brain it should. They use this very fancy techniques these days, like functional magnetic resonance imaging. You can literally see a person thinking. So when they did that, they realized that the brain was averaging out what the two eyes are seeing. So if it was a cat here and a dog here, I see a cat dog. And the brain doesn't know what to do with it. And it's like, okay, we are processing these things in parallel, but we only need to be parallelizing one thing that we can attend to at a time. So the problem is not that the brain has to operate serially. The problem is that the attention of the brain is serial, but it's not the processing that's serial. The processing it's like a GPU, that thing. It computes at the same time. But
doesn't it just like a CPU just multitask very quickly?
What multitask?
There's one task, but it's happening so fast that you feel like sometimes that you're doing...
So what's doing the multitasking is the attention agent. So the attention is attending to one thing at a time.
Mm-hmm.
Yes. But the computation engine is very parallel. So that's the issue. It's like the problem is our perception. The perception is the one that's serial. But the brain itself is not... Yeah, the neural nets are very, very parallel and redundant.
Well, sure. I'm sure we have lots of cores. Right.
We have a lot of cores.
Yeah.
Yeah.
That can work at the same time.
Yeah, NVIDIA can only dream about this kind of head.
But it's also like one opinion on the world is that everybody kind of sees their own reality.
Yeah.
Or in a certain sense that is definitely...
No, that's true.
And sometimes people can even see things that
don't exist.
Yeah.
Because, I mean, if you think about it, talking about simulations, I mean, when I say I'm looking at this room now, I'm not looking at this room. I'm perceiving the simulation of this room by my brain. That's all I'm doing. Because remember, what goes raw into my eyes is just photons. And the photons, when they get up here, the brain makes up what it thinks the photons are. And then ultimately, my reality is my simulation. So there's nothing, I mean, we joke about this in the bank because we need real-time systems, right? And then there's this guy who's always like, nothing is real-time. Because that's true. There's literally nothing that's real-time. Like, nothing is, it takes what? It takes 8 minutes for light to reach Earth from the sun. If the sun was to explode and disappear, let's say if the sun became a black hole, we'll take 8 minutes to know. We wouldn't know only up until 8 minutes later. Right? So nothing is real time. Even reality itself is not real time. It takes some amount of time for light to the photons to shine on you, to reach my eyes, for the brain to see. That's not real time.
But we kind of feel that consciousness is above time. Time is like one of these concepts that, what is it? It's meant to all exist all at once, even with, I think, part of that multiverse and parallel. It's still kind of, it's the fourth dimension. Or
I have decided that I don't understand time.
no.
Yeah. So it's like there's a Stephen Hawking wrote in his book, Brief History of Time.
I think in terms of it's the limitation in terms of our physical versus spiritual nature, because I'm still kind of religious or spiritual, so I do.
Yeah, because there's this question that what time did God create the universe? And it's like, if there was time by then, where was God? Because it's like God must exist in a time space to create time. But apparently there was some guy, I think it was Copernicus or something, who was like a believer and a physicist. But then he made the argument that time is a property. So like God is a property that does not require time.
Yeah.
And it's like, what is that? But
I also feel like that soul is outside of time.
Soul.
Yeah. Just on my feeling level, that consciousness or soul, it doesn't exist in the same.
There is an Oxford mathematics professor called Daniel Dennett. He argues that consciousness or qualia or the soul, it's an emergent property of information processing.
Right?
So there is no soul. It's just that it's the byproduct of thinking. Yeah. So
okay, I also think that lots of smart people, they over intellectualize things. And whatever the concept of the soul, there's something that a lot of people feel. So whether you're thinking a ghost or whether you're thinking consciousness or something, there's a huge element, and that's kind of what I mean with us not understanding things. People sometimes, especially very smart people, they try to feel like they want to understand everything perfectly, and they come up with, but sometimes these bogus things like there is no consciousness or soul, or when all throughout history, I know people felt it, and that's what there's also in the traditional wisdom, there's wisdom. In terms of the chemicals and stuff, what we know is what we can observe and measure. And we kind of can say, okay, if we're monitoring the brain, then certain chemicals are firing and there's lots of stuff. We learned about it, but they still can't make or anywhere close to really a happiness felt.
Let me give you an example.
If we understood it, we could also just give people a pill and, you're happy and everything
forever.
Yeah. You're just living a dream.
So you all know Harari wrote in his book, Sapiens. He gave two examples, which I really like. So one example he gave was Mario Götze, the German footballer who won them the World Cup with a very nice kick. And then he said, after he scored that ball, what do you think is happening when he's happy? I mean, he's happy, screaming, right? But what's really happening is that the brain started producing a hormone that,
No, I have to tell you this. It's like when earlier in my life, I was a bit lost and as a young adult, and I suffered with depression a bit as a by-consequence of my actions.
Yeah.
So later learned. But then when I was suffering with depression, my dad, who was very scientific, he would say, well, if you just think about it, those are just chemicals in your brain. I'm like, this doesn't help me.
Not helpful.
But how do I switch them off,
Yeah, I hear you. I mean, there is another example where this military lady went to test, this journalist went to test military technology. So this technology, there was a helmet. The helmet is designed to suppress certain brain activities. So remove the noise and then you get into this shooting simulation, and then you need to shoot people that are taking you. The lady wore that thing. She did the experiment without the helmet, and then wore the helmet and did the shooting, and he killed all of them. And then the reason was when the helmet was on, she didn't feel hunger or sadness or anything. She was just laser focused on the enemies coming. Apparently, this was so addictive that she wanted to go in again and say, "But this is military tech now. We can't give you this military tech." But it's exactly that. It's that all these chemicals, all this neurotransmission that's happening in the brain, it's the simulation of you know that you can make somebody feel pain without touching them anyway. You know.
Mm.
So I always like to give this example that. I mean, this may be an inappropriate thing, but I'm sure that this shouldn't be a problem. It's like if you think about what happens when people have wet dreams. So we understand the mechanics of sex, that there is some physical activity that needs to happen for for people to. So, but if you're having a wet dream, you're literally standing still. You're not touching anything. But the brain is convinced that you are engaged in intercourse to the point where you can ejaculate.
Well, you're probably rubbing in your dream.
I don't think so.
You're scratching at least. But look. From what I understand, for women, it is mostly mental, more so than physical. And actually, for me, as I get older, it is too.
But the fact
is a youngster, so it is. I mean, that's a whole different subject altogether.
But it's simulations. I think that's the point of the complexity of simulations. It's. I mean, okay. I wanted to say, because you are what an Orthodox Christian, you say, but I think we. So
Orthodox.
Orthodox, not
unorthodox.
Oh, okay. So Yuval Noah Harari speaks about stories, ne?
Yeah.
So, like for example, the way money is a story. So it's like a story that he calls it imagined realities. So we imagine a reality and then we collectively believe in it. So if like I stopped believing in the dollar, for example.
Okay, or like a cult.
Yeah.
A good example is what we call.
But a good example, he says, is this. So apparently, he makes this argument that the reason why humans became the humans that we are now, the animal that we are, and then we're on top of the food chain, we are the most intelligent animal, technically speaking, is because of stories. So we started telling each other stories. Like we can collaborate with people that we don't even know anything about, as long as we believe in the same concept. I can get a lawyer from Israel, and then he will represent me in court, but I know nothing about that Israeli, and they're representing me because me and the person, we believe in the concept of law as a story. But monkeys can't do that because they cannot like collaborate. The only way to collaborate is if you're part of the system and then they trust you. But he says, because of that, you cannot convince a monkey to give you the monkey that they have, the banana that they have now, because they're going to find more bananas in monkey heaven. A monkey will never do that. But you can ask a human, intelligent as we are, to do something at the service of God because they will find more when they get to heaven. So you see, that imagined reality and the imagined order that we're talking about, that doesn't affect monkeys because monkeys can't tell stories. He also says this thing that if a monkey goes to drink water or something, then it finds a lion there, it will just come back and say, I found a lion in the river, or you make a sound that means that. But when a human does it, he'll say, I found this lion that seemed to be brown and then it had a black tail and then it was drinking that water, and then when it was drinking across the river, there was a crocodile. Do you know what I mean? You're just telling stories with the language that we have that have nothing to do with reporting that there is a monkey in the river. He further makes.
Do you think this is an advantage of a monkey, or you're kind of?
It's a protection of monkeys against imaginary things. So because monkeys don't imagine heaven, then they don't have to deal with the consequences of imagining heaven.
But kind of, it's also saying stories are the most important thing, or maybe a communication. I would like, what makes sense to me is, for sure, language, writing, it's all us just communicating. It's the tool for us to communicate and actually interact. And I'm certain that there's truth to the element of Ubuntu, and that actually the thing, if we figure out the true nature of the universe, that it's going to actually tell us that how we're interconnected.
Yes.
And how this whole system works.
Yes.
That story of religion or spirituality is the most popular story that's ever been told.
Yes.
Not just Christianity and the Bible is the biggest book, but the general story around the place, there's lots of similarities. And
at a great cost, by the way, is the most popular story that's being told at a very great cost to humanity. Like lots of death, lots of things that were actually, because I mean, if you think about,
but look, that's not the story's fault. I know what you're talking about, and sure, lots of it's one of the easiest things to do. The most horrible things is in the name of religion, and God, when you're actually committing atrocities according to your fundamental belief. If you self-examine it, but people find reasons why it's okay to do. But that's not the story's fault. That's the people's understanding of the story, because I still feel like that story, we haven't really figured it out. There's also, I can't really say the Bible is literal. It's a story. It's trying to tell us something.
Yeah.
But what the real thing behind that story that it's telling us about the nature of life is or history.
It's interesting, isn't it? Because if you think about, so one of the things that they discovered in neuroscience is that the brain, so we have like old brains like limbic system and other things in the brain. Then we have what we call the neocortex, which is
the dinosaur existed. We had the reptilian brain.
Yeah. So the neocortex is like the intellectual brain, basically. But what they found is that the neocortex is made of the same circuit. So there's no region of the neocortex that differs with another region. Mm-hmm. It's all the same. So the same circuit can compute and produce such different beliefs. Because if you think about the stories that, like some people in the African savannah, when they were wondering, how did we get here? What are the stars? The stories that they told themselves together is very different from the people in, like, I don't know, in the Amazon in Brazil. And we're all using the same brains to do that. So it's like...
look, some of the details of the stories are all vastly different, but there's core concepts which are almost always the same.
Absolutely. Like, where did we come from?
Well, that's the question, but kind of core concepts that we should be good to each other, that maybe stars are important, that... Yeah, but maybe primarily that life is a reflection of how we are to other people.
A reflection of how we are to other people. That's interesting.
Like, the simplest way I've heard it say that I understand life to be, and for happiness is you get what you give. From Pinocchio, maybe, but she's giving advice to Pinocchio, but kind of she's the spirit from Spiritual is telling him this. But it's kind of a similar concept to karma, and karma doesn't just apply to bad karma, which I also feel like my emotional problems when I had them, the way that I've kind of figured them out and somehow managed to resolve them. Because it's been a long time I suffered actually with depression, so some element of that has worked. Was by acknowledging that they were happening to me because I was acting out to other people. I was passing on my pain to other people, and then that energy was coming back to me. Whereas in a different sense now, I feel like paying it forward and doing good for people. It's not an immediate thing, but that interaction is fundamental to my own purpose and happiness.
Yeah, I mean, I like to imagine us as like a let's say a system, a physical process where you are a particle, you are interacting with other particles. So your interaction with other particles results in your position. So it's like, yeah, life is happening to you, but you're also happening to life. And certain outcomes become those outcomes because of your input, of your contribution to to that. I mean, the only thing that I really do believe in is luck. I mean, so I believe in the concept of luck. Yeah, I believe in the concept of being lucky.
Oh, I don't.
Yeah. So I actually, even when I reflect on my career, where did I come from? How did I get here? Most of it was just the luck.
Maybe one day the dots will come in place. What do you think it's luck? But I'm sure whatever success you've had so far and may achieve far more in the future. I feel like you well deserve it. And from my perspective, I feel like if I'm a good person, I get lucky.
Mm-hmm.
And if I'm getting unlucky, I kind of question myself. Maybe one part which I missed out, because maybe it's not. I don't know in the African belief how much it is, but that we are divine. There's an element of human beings. One part is that we're interconnected, and the other part is that we also are one part of our nature is divine. And that kind of, in a Christian sense, that we're all God's children. And God is in all of us and Holy Spirit.
Divine as in like we never die?
No, divine as in part of that one consciousness or God.
So do you, from a Christian perspective, do you really believe that when we die, we go to heaven?
No, okay, but I think I'm still a Christian, and kind of just, I don't know if there's so many different understandings of what even Christianity is and stuff. So from what I understand of Christianity, it's still in line with what I'm understanding so far of the universe.
Yes.
Same as the other beliefs and kind of the commonalities. But yeah, on the topic of heaven, look, dude, for me, the simplest is it's game theory. Eh? And I kind of the way I simplistically, because it's also figuring it out. I was making a joke. You watched the Hitchhiker's Guide to the Galaxy. I recently turned 42, and then I was like, I was meant to figure out the meaning of life.
That's the number.
Yeah. Of the universe. I haven't done it, and maybe now it's time to give up and just live my life and focus on other things, because maybe it's not meant to. It's not my role in life is not to figure out what That's maybe not the question that I should be asking myself. Although it is also human nature to do that. The other side to that story is that it's also human nature to do that and to actually say, who am I? Why am I here? What is this life about? I'm pretty sure every human being on the planet has asked themselves that at some point. So, yeah, I kind of feel it's like a game, and if finish, I'll get to school. I'll see what it's about. I don't know about heaven and hell, and obviously in the simplistic sense of cloud and hell, no, but maybe this, because you can be in hell on earth. Well, you can be in such a depressed state and mental that
at least the way that we imagine hell to be, right? Because we imagine hell to be this horrible place. Like when I was growing up,
where it's just pure pain, but you can be in a place of pain and depression in life, where it can't really be. There's nothing that you just want to feel better, and you feeling horrible, and not partially physically, but it's mostly your emotions inside. You're just unhappy.
I agree.
Yeah. So kind of that state in a extended period of time. I mean, that's kind of maybe one element. It's like if you really see that, okay, you really played it wrong, you just messed everybody else over, and maybe you even got away with it, but at that point you're going to find out, hey, you played it wrong, and now you're going to get some of the processing of that karma, or you get what you give.
Yeah.
Because also I do kind of feel that even if you're cheating, and even if you get away with it in this life, there is, God will judge at the end in some capacity. There is some element of you're going to get a score for the life that you lived.
Richard Dawkins has this joke. I don't know if you know Richard Dawkins. He wrote that book, The God Delusion. I read it when I was in university, and then I went into a spiral thinking about existential crisis stuff. But he wrote The God Delusion. He likes to joke that if he dies and then goes to hell, and then God asks him, "Oh, why didn't you believe in me?" He's gonna tell him, "You didn't show me enough evidence." It's like I'm looking for God everywhere. All I see, it's particles and stuff, and then I'm wondering. So it's like, so the joke is that, like, you give me enough evidence that you are here. And I mean, the reason why these things are all in our imaginations is that there's really no evidence of anything. It's just like.
But my perspective is that that's kind of also what I'm referring to in an understanding of the nature of reality, is that we just really so far away from it. I think that once science progresses, because it's also it would be, what's the word, ignorant or bias of us, or to think that we progress to the point where it's kind of the end. There's always new things that humanity is learning, and there's an exponential curve. And there isn't going to be much more of that.
Can we like link the creation and the old, like the Godfather thing to reality? Ne? So we know that our star, the sun, it's going to become what you call a red giant in like some 500 million years or something, and then it's gonna grow bigger, so it's gonna die slowly. So there's two ways that suns can die. Actually, there's like, they can explode into what they call a supernova, or they can become a black hole. So
from what in but okay.
Yeah, and we know many things. I mean, the reason why we speak into a microphone and then we can hear ourselves is because we understand.
No, there's many things, but there's also many things we don't know. There's some things the only things we really have from that stuff is like some pictures that from our light that we passed on through the galaxy, and then it's also scientists then making explanations for it. Those theories might be accurate, but it's not. None of this stuff is really proven. So I'm kind of saying like from kind of what we understand, because all we got is really some pictures of light. And even if there's more things that we can't see, what if the nature of reality actually requires us to understand those waves that are coming? Our brain is constantly. We know that there's electromagnetic waves, and obviously with technology, radio frequencies and Wi-Fi's, and that there's things that exist that we can't see.
Yeah. But it's like, if you think about the design problem where the Earth was designed, I mean, it looks like the Earth was designed to be.
Tell me about the sun going away. Yeah. That I interrupted you.
So what's going to happen, at least from the physics that we know today, is that the sun is going to become what you call a red giant, and then it's going to grow bigger. And as it goes bigger, it's just going to burn Earth and burn all the other planets in the solar system. And also, we know that.
Well, when the sun goes away, then obviously our solar system is not going to.
Yeah. And we also know that even now, as we are, there is constant bombarding of rocks in space, what we call asteroids, that are just basically trying to kill Earth. I mean, there's one that succeeded, which is the 65 million years ago story that killed the dinosaurs. So there is evidence that the Earth is not protected from anything from the nature of reality. Is that actually we're getting lucky because of the gravity of Jupiter and other orbital mechanics that shield Earth from getting damaged compared to other planets, right? We're in what we call a Goldilocks zone, which makes people think this Earth was designed for us and that kind of thing. But these are facts that we know. So is the plan then that I will kill the universe?
I'm very skeptical even about all the scientific stuff. No, look, there's a place often out of the theories that eventually comes into a proven solution.
Yeah.
Maths, I believe in 100% because you have to prove it. Science, of course, is the process of discovery, but part of it is theories. And if it's in this kind of stage, we still don't know really the answer of all these questions and what happened in the past and stuff. So even all those things, not that I don't believe that dinosaurs were 65 billion years ago or whatever, but again, what is time? It's just like that kind of thing. We do know that likely they were dinosaurs and when, right? Question is, does it really matter? Like the sun is not for our conceivable from because the story, which is also very popular around the world, is that something happened, like a flood. A flood is a very popular story that, even in South America, they had stories that Pichu Pichu or somebody, and then there was a bird and there was a, flood. Some of the details differ, but, there's lots of things that previous civilizations might have existed. Maybe different versions of software. Maybe one time that version of software is actually a reptile. We have some reptilian elements. There's different versions of the game, right?
So I read the book, The General and the Genius, which talks about the story of Oppenheimer and the military general who was putting pressure on him to produce the atom bomb. And one of Oppenheimer's colleagues once said that I never thought that as a scientist I could use theoretical physics to kill people. Because remember, atomic energy it's theoretical physics for the most part, because we can't observe those things. There's no experimental things. But literally, theoretical physics created atom bombs. Something that can physically manifest into killing actual people that came out of theories of quantum mechanics, So I fear science a lot because I think science is super powerful. I feel like the more we understand science, the more we can convert it into reality. Like I was saying, we understood quantum mechanics and then we made microchips out of it. And quantum mechanics is very hard stuff.
Somewhat. I can't say that we understood quantum mechanics. Does anybody really say that they understand?
We productized it.
It's still full of theories and people argue on the different variations in quantum
But we
mechanics.
understand enough to build microchips. To understand. So we don't know everything. I mean, people are still arguing about what really is quantum mechanics. But we understood it enough for us to be able to build microchips.
No, sure.
And then we understood it enough for us to build atom bomb.
Yeah.
Right? And because I also sort of find it difficult to just believe these things, like especially theoretical physics. But it's actually shocking how. So, for example, this guy called Paul Dirac, was an Oxford physicist. He predicted, I think, 20 years ahead or something, some crazy thing. He did the math, and then the mathematics calculated that there must be a particle that is inside the neutron or something like that, or he predicted the neutron. I don't remember exactly. And then he predicted that it should have its antiparticle. At the time when he made those predictions, no one had an idea. They actually thought that the smallest particle at the time was the smallest one, right? But then when time passed and then people could build particle accelerators that can smash this protons together and others, they found the particle, right? They found the particle and they found it with its with its antiparticle. There are these other guys who predict bosons, and these guys, they predict with mathematics, and then later experimental physicists observe the particles with the right weight, with the right mass, the right. Do you know what I mean? So I feel like physics is very, very, very powerful.
Yeah. No, look, I'm not discounting that there's good to science and the scientific method and the process and stuff, and many times that it helps with the progress and it gets to the solution, and then it's actually helps us with our understanding. But what we also can't discount is that there were many scientific theories that people believed for a long time
that are wrong,
that were just plainly wrong, and actually probably much more of those than the ones that turned out to be correct.
Yeah.
And all of those were thought up by very smart people at the time.
Yeah. It is it's life, man. This thing is complicated. Nothing happens smoothly in life. There's like this one theory, the string theory, where they argue that the universe is made of strings and stuff. And they can produce the mathematics for it, and other people are like, we don't believe you. And this been done by MIT professors, So I agree that even your reputation does not necessarily give you the right to make, astounding claims about the nature of reality just because you think you're an MIT professor.
I'll tell you, I agree. It's part of our own ego that starts thinking that kind of we know it all, that we know better than other people. If you 100% believe in whatever your theories are, because there has to be in the part of learning an element that you also say, well, I actually don't know and I'm open to being wrong. But I think that one thing I'm almost certain about is when you do have children, you'll change you modify your views on reality and these same questions.
It's a life-changing experience. I'm sure that some balls get loose somewhere or get hardened somewhere, and then you have a different perspective of,
Okay, maybe from that perspective, this might be a good one. I've said it so many times, I kind of hate myself going back into it, repeating it. But my experience in life was kind of up until my first child was born, 14 years ago, 15 or 14. I was very scientific in a sense that if it wasn't science or if it was anything to do mildly esoteric, to do with stars or to do with anything, if it's not science, I don't care. The only thing that was really real to me was kind of what science did. But then just that experience changed. Because from my perspective, what did I do? I want to be crude, but I just reproduced, and this whole process which happens afterwards, and even if you like how the human body gets formed into the fetus, it's like the most advanced science you could ever think of. And then actually this thing that comes out is a person that's
can ask what is my name.
That their own person. You don't create it. They're their own person. They have their own character and consciousness. And they kind of, I don't know. It's just, it changed it for me. For like that, actually, that experience brought on like me starting to ask questions about
what could be true out there.
Or, into the spiritual side.
Yeah.
Because actually up until that point, I really don't care.
So one of the things that I like to make a distinction of is that for me, the power of science, where I find power in science is not that we know everything. Actually, most times when people are advocates of science, they come out as though they think they know everything. For example, when I'm saying that with the current physics that we have, we know that the sun is going to explode, and then it sounds as if you think you know all. But actually, the most humbling thing about science for me has been knowing how much we don't know, And most people would prefer to fill the blanks with some ideology or some belief, because, we don't like being ignorant. We don't like the idea of not knowing. So it's like, if somebody asks what happened before the Big Bang, someone would say, oh no, what happened before the Big Bang? There was what that they are just imagining, because we don't know anything. But when you look at the real science, you realize, oh damn, actually we don't know anything. So that's the humbling thing for me. It's the vastness of space, for example, just how big space is, that humbles me. So most people think that being scientifically minded sort of gives you some intellectual arrogance, but my experience of it have been that it grounds me into realizing first how small I am, how much I don't know, and left an excitement of what else is out there that is waiting for us to discover.
Yeah.
So it gives me no intellectual ground of being right over someone, but it basically humbles me in knowing just how much. I mean, we had a long conversation, you and I, now, about just how much we don't know about ourselves, about our body, about the nature of the universe. And oftentimes, science is the one that is used to tell us that we don't know. That's the most. The claim now, for example, is that with the current telescopes that we have, the Hubble one, the James Webb telescope that just went online, that we can literally look back in time 1 second after the Big Bang. So what that means is that, the way satellites work is that they're basically looking for light, like I said, right? Then we can redshift light to sort of look at all these galaxies and blah, blah, blah. But the current scientific model can explain what was happening to the universe 1 second after the Big Bang. And these are published papers, because, remember, one of the things I don't like, lest we become Americans where we don't agree what the truth is, because it's like, in America, you can just manufacture the truth. So you can just manufacture it right now, right here. And then, but as humans, we need to agree on things. So, for example, if we agree that we believe in the scientific process, that if a PhD student who's studying the movement of galaxies comes and tells us that the data shows that this is what's happening, and then it gets peer reviewed by people, then that is our new knowledge. So if a scientist comes up with a new particle, and then we test the theory of that particle with a Large Hadron Collider or something, and we find it, then we update our beliefs. I have a Bayesian probability tattoo on my hand, because I believe in priors and posteriors. So it's like you need to update your beliefs because evidence has changed. So it's the same way that I'm saying that we may initially assume that we know, but with new data, we update our belief that we actually don't know. So,
well, we can definitely agree on that, because, I'm not, again.
Yeah, so
they're saying that all scientific people are egotistical and want to do it for the ego. Of course not. But it's also, it is a trap that many do get into. It's easy to get a little bit out of balance and think too much of yourself, rather than like I think of life like one half physical, one half spiritual, and two passes in the middle. They're both important.
Yeah, and to your point, like, regardless of how scientific one thinks they are, like there's non-scientific things that we experience nonetheless, like heartbreak. It doesn't matter how scientific I think I am. I literally get heartbroken as a person, and that's my nature. That's my reality. That's the pain I'm feeling. It's real in that sense.
Yeah, back to the happiness moment.
Yes. So there are non-scientific things, but it's just that also spirituality. Like people who meditate, for example, they try to connect to the spiritual realms and other things. They use it for those kind of things. Just that it gets a bit stretched sometimes when we want to use spiritual things to explain physical stuff. And that's where I think these two worlds collide. They collide when so for example, maybe if let's say the Bible wants to opine about the beginning of the universe, I feel like the Bible must be talking to us about how to be spiritual, not to try to explain natural processes, because they don't know. I mean, how do they measure that? So do you know what I mean? I feel like we should separate the world so that.
Yeah, but you kind of said that it's what separates us, humanity, from animals is stories, and that story is definitely the biggest one that humanity's ever told.
Yeah.
From my perspective, nothing. It's often like to the church, to the institution, the scientific. It was kind of been a threat, because if you're taking the Bible literally,
Yeah.
like God made the world in 7 days and 40 days and 40 nights, so those there's lots of numbers which kind of repeat in the Bible, or in spiritual texts, like they literally mean that's what it was. I think maybe that's some maths that after a while we'll kind of figure out, but it's now just like a children's story to get you the kind of concept of the thing. And I don't think anything that science has discovered so far, in my understanding of the Bible, is contradictory. So I kind of feel they are complementary, that it's kind of explaining similar things that the Bible is explaining.
Well, the thing is the age of the universe. Well, the Bible and science disagree a lot, like in terms of how old we are as a planet, for example. Or say,
but as this civilization, like I would ask you that thing of the sun, because even as this civilization, we're really not 10,000 years. How long?
Mm-hmm. We're not. We're still young. As like this version.
What's billions of years? Because I don't know if it's 10,000 years in the last 2000 something, where we're really writing and keeping track of everything, and it's going so fast. I don't know when's it. It's only 10,000 years. Our life is like 100 years if we're lucky.
Yeah, and the universe is big, bruh. So it's like this. It's so big. It's like, what are we doing here? What is happening?
Words of wisdom from Mabu. But yeah, maybe we should call it. Should we keep going? Yeah, we should wrap it up. 8 minutes left to WG. Is it? Okay. Well, I'm gonna tell you something that I told Misha yesterday. It's a good compliment, and I hope that. I don't know about all the esoteric stuff that doesn't really have anything to with professional and stuff. But I told Misha yesterday that you're coming on the podcast. And here's the truth, said, there's genius, and then there's genius, and there's genius that can explain to you. And I'm not very technical, but I can listen to the guy speak all day.
That's a great compliment.
Yeah, so that is a very great compliment. So to the future Misha, when this gets released, I hope you watched it. I hope you enjoyed. And I thank you very much. I guess, as you can see, we can talk for hours. We can keep going. And I hope to talk to you again. And thank you very much for coming past.
Thanks for having me. Actually, this conversation went like completely left interest. Yeah, I didn't know how it was going to be. So I enjoyed this. I enjoyed this very thoroughly. Although I do think maybe we should have been less technical, hopefully for other people,
or maybe less esoteric at the end, but I don't know.
Yeah, but it was great. Thank you so much, Ivan.